Hi, my name is Bob Grenier and I'm a volunteer with the Martin Fleischmann Memorial Project. Okay, so this is a presentation that I've been working on for precisely today, and it's still only like half done, so I've called this part one. And even part one is not completely finished because I had some other things to do today. Can you hear me before I go on? Can everyone hear me? So you're a little bit behind, so I'll wait for you. Okay, so when I know it's good to go. Okay, perfect, you can hear me. Good, so when the project started in 2012, I was called Banker Bob at the Occupy London protests, and my brother got quite interested in this research, and he was very kind that he said that you know, this is kind of my thing and I want to help out, and he is a composer, and back then he we didn't know which way it would go, but the idea originally was to do a Kickstarter and put out some sort of easy to do experiment and use the Kickstarter to raise the funds to enable those to go to 5 laboratories around the world that could do it. We're at a stage now, I think by the end of this presentation, you will understand, I think, that we're at a stage where a 5-year-old could do it and any primary school could do the experiment. And so this is really, really exciting. It's early doors on the analysis, but the analysis, I couldn't really have imagined it to be better for a first attempt. What's really important is that when Dave did the first experiment and the second experiment, both of them produced these magnetic particles. It's not unsurprising, but they did. So he had a replication 1-for-1. I didn't even bother rerunning my experiment. You saw what I did. It was one from the previous weekend. I looked at it, and the particle that I found was absolutely magical. And hopefully I will be able to demonstrate to you today why that is absolutely magical. And then I asked Alan, and Alan has not been anywhere for a year, and he was due to leave today to go on a break. And he very, very graciously said that he would have a go at this experiment, and he found time to put it on the scanning electron microscope, and I was absolutely blown away with the results, which you're going to see. Stepping back a little bit, so we wanted to have a theme song for the Kickstarter. Now it doesn't look like we need to do a Kickstarter for at least this, in terms of having an experiment that everyone can replicate very easily. And so I just wanted to share this song with you because it's the lyrics. He actually wrote it 22 years ago. So in the same year that Takaaki Matsumoto concluded his research into the steps to the discovery of electronuclear collapse, my brother wrote this song. And you can listen to the lyrics, play it back. It's a short song, but I think its words, if you can hear it, are they're very pertinent now, and in every way. And I couldn't have imagined it being better. But he's given the song to the project, so thank you to my brother Guy. And we'll play this, and then I don't know how much I'm going to get through tonight, but I've got some stunning stuff to share with you. And also, if we can get to them, 4 slides from O-Day, which in their own right are very thought-provoking, I hope. So what I'm going to show you, this is my brother here. Hello, that's my brother. And he's going to play this song for you. And then we're going to look at the video that we just, you were just having a look through. And we will play that now. So I'm going to kill my voice. Okay, so that was my brother. I don't know if you heard the lyrics there. I'm sorry, it was probably a little bit blown out the first time. I was going to put the words over the page, but it wasn't so important to do that today. But it's what is it? What is it? I can go like here. It's essentially starts off, I can feel the day when it's not work, it's play, that's the people's right, yeah. Sitting in the sun, making love, having fun, that's the people's rights, yeah. The stifling of technology is a crime. To make something fail, to fail is a waste of time. They should make things to last, stop getting stuck in the past. We'll feed the world with ease, reduce the working week. Anyway, I will reissue it. I will try and get the audio a little bit better. It was just an impromptu recording 8 years ago. And there we go. You just got the raw thing. So I'll get on with the main thing right now. So it's because right at the end it goes, working for a new sun, and the system's out of date now. And basically it's the fact that we're actually working for a new sun right now, a sun that we can hold in our hands and go to any point in the universe. The fact that this song was written 22 years ago, and before we even got close to understanding how the sun works and how low energy nuclear reactions work, that was the lyric. So I just thought it's a little bit freaky for me listening to it now. So anyway, I'm going to go to the video there of the one that I was showing you earlier, or rather we were discussing, if I can find it. Now what I've done with this is I have scaled it to 4K, although it's only a 1080p stream that you're watching this on. But I will make this available as a download. Okay, so let's go to this. So essentially what this experiment is, he's got an ultrasonic horn at the top. He's got an ultrasonic horn at the top, and I'm going to get a bigger mouse pointer here because people find that easier for me to work with, or rather be able to see what they're doing. No, I didn't want to do that. Give me a second. Right, it should be nice and big. Okay, so what we got here is the ultrasonic horn. It doesn't really matter what frequency that is. Down here there's a big iron plate, and he says in his notes in Russian, A classic experience with ultrasound. Several interesting phenomena occurring in a strong ultrasonic field are demonstrated at once. A standing ultrasonic wave, so basically whatever the frequency is, he's got n lambda plus a half lambda distance between the two, so that you end up with a standing wave. And we've discussed this at great length in quantum coherent Solin reactor and other reactors. It's important that you make your reactor vessels relevant to the frequency, particularly if it's low frequency, to be able to get the standing waves. And so a standing ultrasonic wave is generated between the transducer top and a massive steel plate at the bottom. The liquid in the syringe is ethyl alcohol. Getting on the end of the emitter, the liquid is sprayed into smaller droplets, which, due to the sound pressure, quickly collect in the nodes by pressure planes of the standing wave. The next slower process is the coagulation of the particles into the nodal planes due to the forces of attraction between the particles that arise in the ultrasonic field. As a result, one, sometimes several, large drops is formed in each nodal plane. Sometimes these droplets become unstable and spray, creating a secondary process very similar to the first. Sometimes they just rise and then fall down. Now, one could look at this as an analog for what we've been observing. And if you look at the whole process, when it starts off, you get one in each place, and then sometimes you get more. But it doesn't like to have more than two, ideally, in a location. And as he keeps feeding it in, you'll see it kind of growing in intensity and growing in intensity, and then you get two appearing. And one of them is very different from the other. And there will be artifacts in this video that I have produced here. But the experiment is so simple that it can be conducted a little bit more complicated, let's be fair, than the normal ultra experiments. But this ultra experiment shows this pairing, this yin and yang pairing at the end. And so I think some of you had noticed there's some very special things going on. And before we go to that again, I want to just pull up the whole start frame from here, if I can get it. I don't know whether I put that in. Maybe I've got it in here. I probably got it in here. Yes, I've got it in here. Okay, so damn it. My computer's struggling again now. Right. What I want to bear you to hold in mind is something that actually I found a little surprising when I first saw it, and I wasn't sure, and I didn't want to really mention it. But in this tornado that I took from Thomas Kaminsky's ultrasonic tank, where we had the sprites and everything, in the center there was a bright feature, and it is very central to this overall structure, and it's central to the vortex column as well. And I thought maybe this is just somehow catching the light, and it isn't so significant. But I think as we go through this, you'll see something similar. So let's go ahead and press play on it. So at the moment, it tends to coalesce predominantly into one. Now, I don't know if you can see already, there's kind of like what looks like an evil twin. It's like a dark one, particularly down the bottom here. You've got the bright one on this side, and then the dark one on this side. And he keeps pumping it, Now, just to note that there is a light on this side. You can see up here. So this is just a preliminary comment that I'm making here. It's not, one that I'm going to be setting in stone. But because the experiment is so simple, there's a real opportunity for someone to nail this and find out whether what we're seeing is actually what we're seeing, or whether it's just an artifact of the lighting in the environment. But it's definitely got a light on this side. And if I step through here, you'll see this is spiraling in and it comes into the back side. And it's feeding the one at the back. Not the one at the front, it's feeding the one at the back. And this one suddenly gets brighter. It's feeding in, it's feeding in. The one up here, in fact, it looks like it's 4. It becomes unstable, it blows out, and then it tries to get stability. You even have this kind of like crazy jump into the stable node, and it orbits round a little bit. And it becomes completely unstable and blows up and rains down. So this is kind of what he's talking about. But at no point does he mention these 2 balls. You can see it's very clear down here, these 2 balls. And the one that was formerly dark, the evil twin, gets very bright sometimes. And I think it's this one and this one you'll see get very bright. So the evil twin here is quite dark. It's almost transparent here. Again, we need to be careful whether these are artifacts. But you can see here particularly, look at it. This is the evil twin, and it's sucking the material in to this side. Sucking it in. Sucking it in. The back one here is sucking it in. Stepping forward, you can see that there's the white one and the not so white one here. I hope this is clear. Is this clear? Is this clear? So I'm stepping forward. I'm stepping forward. Now, if you have a resonant system and you look, this one's eating this, the one at the back is eating it. Now in this last segment, it really becomes very interesting what you see. Look at this one. There's the back one which is eating the material is almost like it's transparent, and the front one is basically white. The back one is feeding on this. It's feeding. Okay, in this last section, it becomes very, very interesting, and in fact, there's a couple of times it happens in the whole video, but we'll just step through this last bit here. Okay, so you can now see there's 3 spots up here. One of them's very bright, the other 2 are not so bright, and then they merge down. Okay. So look at this one, and I think it's this one as we step towards the end here. Right. See if I get it right. This one I think goes first. This one up here is, I think it is. This one is not bright at all. It might be this one, but anyway, we'll see. It's practically transparent, this one. And now we see almost like a bright spot in the middle. Look, it starts to get bright. There's no more material being fed to it. This one's already rather bright. Oh no, I'm actually sorry. It's the one at the bottom here. This one. Watch it. I'm stepping back. So it's almost transparent. And as I step forward, this one doesn't basically change its illumination. I think it's one of these 2 as well. Watch this one here. Look, it's getting brighter. It's getting brighter. It's getting brighter. And I think it's maybe this one. It's extremely bright here. Just before the end. And it's the brightest of anyone. And as he turns the sound off, boom, it immediately collapses, becomes transparent, and then falls to the ground. Wind that back, and there's one up here that goes bright as well. This one here is bright. This one's bright. So the one that's formerly transparent, so it's transparent here, and you can see that there's some feeding between the 2. Some feeding, and at different points in this video, you can see that the clear one has this white spot in it, like I am showing you in this. Like there's a white spot in the center of whatever the structure is. And That is what I'm saying I'm seeing. Maybe I'm wrong. But I think, given that we're seeing these two spots, these hydrodynamic or magnetohydrodynamic structures, and they are, you have an evil twin. So watch this one at the bottom again. So there's nothing there, nothing there. It's practically transparent. There is a linkage between them, but it starts to get bright. It gets bright, really bright. And this one's feeding, they're feeding each other over here. And then as soon as he turns the sound off, boom, it collapses, becomes transparent again, and goes to the bottom. So, yes, a uniform illumination is needed. Essentially, Takaaki Matsumoto felt that he had observed what he called a black hole and a white hole. A black hole, matter going in, a white hole, matter coming out. And we'll show his understanding, and I'll read through his description of what he thought was going on there. And hopefully, if I can dig them up, I will be able to show you data from the 10 yen coin exposed to Amasa gas, where you have a structure that looks like structures we've seen many times before, but it has the arrangement of matter that follows the understanding of Takaaki Matsumoto. And it's not the only case. There are many, many cases. But these are the basic clusters of two. And Ken Shoulders, you can find one, and then there's maybe it's got an evil twin, or the evil twin has got a evil. They're yin and yang. They go together. But they can be apart, and Matsumoto is suggesting there is a wormhole that links them. So there is something that pulls them together if they come apart, and this would explain why Ken Shoulders was able to observe these things splitting up, and then when they come through a material, they come and join together again. And because they're self-similar, and in this video I will go over some of the self-similar material that I've shared in the past that may not have been fully understood. And within a macro one of these, they're comprised of many smaller versions of the thing. And so the big ones are linked, but then the big ones, if they split up into little ones, the little ones in them are linked to that particular big one, and the other one's linked to the other big one. And you can think of it, and I do for the minute, when the facts change, I'll change my understanding. But at the moment, I think there are predominantly north type pole magnetic charges, and there are predominantly south type pole magnetic charges, and they stick together and they align themselves, and so they act like one big north magnetic charge and then another south magnetic charge, but if they split up, they split up in their own like family group. But the whole thing, once it's entangled with its mesh of feeder lines, those feeder lines, those little wormholes, pull the whole structure back together when it has an opportunity to reunite. And but I mean, you could smash it up and fragments go off, and you can imagine that this might be the cause of different quanta strange radiation. So I'm going to share some things. It's not absolutely conclusive today, but I think they are definitely food for thought. Okay, so hello to my wife, if you're still listening. Thank you for joining in here. So give me just a second and I will get the presentation up. So I'm calling this ball lightning and coherent nuclear transmutation. Part 1, because I have no belief that I'm going to get through what I have to share tonight. So I'm going to call this part 1. Also known as the new eternal fire, because this is not new in the universe. This has always been there. And this is 16th of April 2018, and what you can see in the background there is the ball burn sample from John Hutchison. We're going to revisit that because that's where we left off in the last presentation. And you can see the kind of very highly disrupted area on the right, which is the same shape as the large cavity that's been taken out of the material on the left. So without further ado, we'll step forward. So this is the twin feature on John Hutchison's 1980s steel ball burn sample. We're going to look at a different set of different materials in different experiments running at different temperatures that exhibit the same kind of features. And the features I'm going to focus on today are yin and yang, whichever which way around it is. One is taking the material away and one is giving it back. So I actually have scanning electron microscopy on this, and this was done before OA was written. And you can see the shape on the right here, and you can see this is largely one side of a hexagon, and this is the other two sides of a hexagon, but it's drawn out to a point. And this is what we see in the hydrodynamic model in the ultra experiments. The thing that confused me a long time about this was over here we have the same structure, but so one is the yin and the yin of the other's yang here, but it seems to be attracted to a much bigger structure here. So these are like little babies of the much bigger structure on the ball burn sample from 1986. And if you look on the pit, I've got a spectrum 56 here for the pit. And 56 is a little bit low count, so it's not so conclusive. But what we do read is a lot of carbon. And as I've said to you many times before, Matsumoto said, if I just get rid of my mugshot here, Matsumoto said that doesn't matter. By 2001, he had written in fusion technology. He says whatever you put in, you tend to get a lot of carbon out, and that is tri-alpha, and you get oxygen. That's the second most abundant element, and that's quad alpha, and then iron. And there's really not a lot of iron left, 5.8% there, and calcium. There shouldn't be any calcium in that stainless steel, but calcium is something that gets synthesized by this technology. Silicon and aluminium, well, you know. They are, I think aluminium is the third most common element on Earth, metal, and silicon is the second most common element on Earth, and it's semi-metal, isn't it? So, so it's not surprising that these things, you already have in the crustal abundance a good guide as to what this technology will produce, and I believe, and I've argued this for a long time, that it is this technology that produced the crustal abundance. And so if you want to know what the likelihood is, you just look at the abundance of table elements in the periodic table. And so on the right here we have spectrum 55, and spectrum 55 is showing not so much carbon. It's 65% by weight over on the left here, and because carbon doesn't weigh much compared to like iron and some of the other elements like calcium, that means that atomically there's quite a lot more than 65% by atom. So 47% here on the other side. Iron is 26%. You're seeing a lot more iron. So I imagine if we go back to the previous frame, we're seeing the carbon that are in these pits. By the way, this is hexagonal, and this is a little one, and this is a large hexagon type shape. And when you go over this structure, and knowing what you know now, you will recognize that this is it's the same pattern repeating on all kinds of different scales. Anyway, so I've got this sample here, and we've got the chrome from the steel, probably the nickel is from the steel, and it has sulfur in there, which is, oh, sorry, that's the next slide. Yeah, so we have that, and what else? Yeah, typical element, sulfur from oxygen, two oxygen go to sulfur 32. Anyway, down the bottom here we have the center spot of this feature, and again it's a fairly low count level, but it has copper in there, high level of copper, and we've got carbon in there and tin. I suspect maybe this is a piece of brass contamination. I don't know, but the fact that this is carbon, and it wasn't just Takaaki Matsumoto that said you tend to get carbon. That is what we've observed in almost every experiment we look at, and it is the claim of Yul Brown that if you take whatever material it is and you expose it to Brown's gas, and for instance his examples, I think in 1992 to politicians, where he got aluminium shavings, iron pieces, and put I think americium-241 or other elements with that. He would load that up, and I've explained how I believe that is happening and how it works in my last Russian presentation, the monopole clutch. But essentially, after it's loaded to a certain period of intensity with the Brown's gas, there is a huge flash, and all of the radioactivity is gone, and what you end up mostly with is carbon. And just bear that in mind, and bear with what I showed you at the beginning of this video, where nothing happens and it keeps eating and it keeps eating and it keeps eating until you get to a critical point, and what Takaaki Matsumoto says, you get a self-collapse, and the self-collapse then causes nuclear regeneration, and you end up with predominantly carbon coming out. And so I will show you the model, and then I will show you the closest thing we have to Brown's gas, which is Amasa gas, in a structure on the 10 yen coin. There's many that I could have chosen, and over the coming months I will share some incredible data from Amasa gas, which proves that it is Lena in a can. So there's one thing to be able to do Lena for 35 quid, but to be able to get gas and just put it on a metal, and essentially as fast as you can get it into the SEM, you can show that you've got Lena. And I'm telling you that it is these figure of 8 structures that are absolutely key. This black hole and this white hole, and they play, and like I say, they can cluster, they can cover a whole structure, but that is the base structure which can quantize, and effectively they are the two EVOs, the two types of EVO that form a pair ordinarily. Okay, so so what you tend to do, and you might have seen this in the Vega experiments, is we end up with a sphere that's half on the surface and half under it. And what I have in the frame here right now is, remember, this is kind of like a mushroom shape. So we've got the top here with this curve on it, and this tail. The tail is very fat here, so maybe there was some precession. It was kind of like, it got locked in the metal here, but it was kind of going like a spinning top, spinning around the pole, this monopole here. And it basically sucked in all of the material, but it's a half sphere of material. There is a slight fall off here, and you might call that the double layer. So outside here, it's essentially flat, but it's affected. And if you look at these structures, it's around these areas that the subquanta are basically a fractal version of the bit that forms the overall structure, that forms the most intensive bit in the center. So essentially what you're doing is you're creating many of these structures, and they're coming together, and they're acting together as one. And when they get to a certain strength, they are able to unify the forces, and you get this kind of thing going on. So this tail, I believe, if the structure had come in and locked itself into the surface and hadn't been continued to fed, you would have a much sharper point to this. And so this is the fuzziness that I think you get. I mean, if you look at the libation disc from Egypt, it is splayed out a little bit, but not to this degree. Anyway, I've done some other things on this where I've overlaid various things, but that's not what I'm going to do today. So here we have the analysis, and in fact I've got it on the microscope, so we can have a quick look at it. Let me get that one in shot. So let me see if I can find it. And we can have a look on the microscope, because it gives us a more real-time feel of what it looks like. I'm gonna have to zoom out. Look at the data on the slide there to keep yourself not from going mad with boredom. Okay, so where are we? It's over here, is it that one? I don't know. Oh no, it's here. Okay. We can have a look at this on the microscope live. Why not? Okay, so in 62, this little sphere here, we can see the sphere is 91.2 by weight, atomic 73. So it's essentially very highly concentrated iron with carbon coming in next, and oxygen and residual amounts. So it's basically iron and carbon and oxygen, but mostly carbon, iron and oxygen. In the center area here in spectrum 61, it's predominantly carbon and oxygen. So there's your triple alpha and your quad alpha again. Almost no iron, so that's the same pattern that we saw before in the yin yang, and other elements here. Chrome is in the metal, and then sodium and these. Remember these elements here, because you're going to see these elements appearing over and over again as I share these structures in different systems, in amasa gas treated materials, in you name it. But these are the things that you see. But if you remember from the structure from the lion, which we'll look at, the two discs, and it threw material from one pole to the other and it hit the top of the wire. It was this crystals of carbon and oxygen, and you'll see those so many times it gets boring after a while. Anyway, so spectrum 63 here again, we've got a lot of oxygen here, so this is moving towards magnetite here. You've got by weight percent, you've got 31%. By atom even, so you got like, it's even worse than that. There's more oxygen. It's not Fe2O3. It's more than that, but it might just be an oxide on the surface. But anyway, oxygen and iron, and this area over here, lots of carbon still by atomic percent, 64% atomic carbon, and you've got oxygen, and then much lower iron here. So it's interesting that you have only 10% of iron in this zone over here, and over here you have a sphere in a spot, or a sphere in a zone, and that is comparing like for like. This was atomic percent. Atomic percent, you got 73.7%. So at the very least, it's doing some segregation. It's doing some separation of the elements in there. Okay. Now what I've done is, this is from the microscope. You can see the pit, and this isn't highly accurate. This is taken from some software that looks at different focusing depths. It gets a bit flat on the bottom because I couldn't see into the hole. But we can actually play this, and you can get a little bit idea of the 3D nature of this. This is a hemisphere here. And you can see this is very much more disrupted there. Okay, so I'm going to go and switch to the live microscope here, and I'm going to get it over so that I can see where I'm doing things here. Okay, so this is the structure that we've just been looking at. Okay, and it's on the Hutchison ball burn sample, and we can play with the polarization here so you can get a different idea. Now, I've toyed for a long time. Has it actually got a sphere of glass in here? Is it silicon dioxide? I don't know. When you do the analysis, you get all of this carbon and oxygen. I mean, is it actually a diamond in there? It looks like it's almost refracting, even live on the camera here. Now, with that level of specular, I can't put my mouse over the screen, but you can see that the hemisphere is slightly buried in the surface, and there is a chamfer kind of area on the outside. So you can imagine that there is a sharp fall off, and then there's a slightly less sharp fall off, and then it just goes to the flat plane around the outside. So I'm going to go over here, and so you get a different idea of what it is there. I'm going to go and zoom in on this, because I need to zoom in on it. Okay. So it's like looking into an eye here. Look at that. It's like a So you can really get an idea of the geometry, and that black, you can see those black spheres. You see that black sphere there that I looked at before, and it was a sphere of iron. I'm going to put it right in the center of the frame. So it's what's in the center of the frame there. In fact, I'm actually able, in the software here, I can change the zoom level. This is not ideal, what I'm just about to do here, so bear with me. It's probably going to complain. I've already unlocked it, so I'm gonna zoom into this like digitally. Right, there we go. So what I'm referring to are these spheres, kind of the center of the frame there, and the one that I did the analysis of somewhere here, and you can see a little bit more close up on that. So you can see the kind of chamfered fall off, and it gets more and more disrupted, and then it's like there's an acceleration zone, let's call it that, and then right in the center there is effectively what I would call an event horizon, and at the event horizon not even this stainless steel can withstand what we're looking at there. It will always be a failure. So I'm trying to zoom right in so you can see right into the base there. There we go. You can see right into the base. So are we looking down the wormhole? Where does that wormhole go? Okay. All right. So let me just scale this so that I can see a little bit more on the screen. Oh no, there's two of me there. That's very upsetting. Let me deal with that. So I'm unnecessarily stressing my computer. Okay, all right. So we'll go there. All right, so that is that feature, and we're gonna have a look at another feature in a little while. But it's not just this ball burn sample. John has sent me a variety of images over the years of various samples, and we're going to look at one of them now, and that is this one. So if I go back here, so I don't know if you can see that, it's a little bit JPEG-y, but in this image you can see a large number of chunks of material removed. Are these a pair? I don't know. These do look like they're a pair. They're kind of linked into each other. But bearing in mind you can get these north and south magnetic charges at any point. But the interesting thing about this is it's very much like Takaaki Matsumoto's paper, where he found that in a palladium deuterium experiment, when he cut open the palladium rod to see, you know, the interior and to examine the interior, what he found was that material had been eaten away from within inside the palladium, and it had been eaten away in spherical sections, predominantly initiating at a grain boundary. So it's this experiment here. It's called Macroscopic Observations of Palladium Used for Cold Fusion, and it's from 1990. And if you go to the MFMP's reaction calculator at nanosoft.co.nz, and developed by Philip Power, and he also developed this wonderful database. If you go to the bottom right and click on a Lena events database, you click on that, you can type in Matsumoto and you'll see this paper, you'll be able to look at it. But what I'm showing you here is this, and so he had this palladium rod and he opened it up, and inside the palladium rod he found that material had been eaten away. And if you actually look at the images, they have these sections here, and you can see that they are circular, and it's eating away, and it starts off with a little bit on the grain boundary and then becomes a sphere and so forth, until it actually eats the whole grain away. And that's inside. Where is the material going? Where is the material going? It's crazy. And whilst I've got it open here, I will just show you something else. I'll go back to the image here. And that is, there's another paper which you can get via the Leonard Events database, and it is, I think it's a search for black holes. It's quite relevant here. And it's experiments with ordinary water. Cold fusion experiments with ordinary water and thin nickel foil. And in it, firstly, you'll see a lot of 8s. So there's 1 8 that are. Now, he used to think these were quad neutron decays. He revised his opinion on that. Here's an example from him of tiny black and white holes. And you have, the one I think that's clearest is this one. Maybe it's not going to be clear on that camera. Let me switch to another camera, which has now got that on it, so I can't do that. Okay, sorry. So this one here, you've got the black hole here and the white hole there. Black hole, white hole. Okay. And then the other paper I want to refer you to is experiments of 1-point cold fusion. And if we look at this, he has these plates, which he does at that time, which was back in 1993. He calls it gravity decay, definitely gravity decay of single neutrons. Well, he did say that after, in 2001, he said that it is very many simultaneous nuclei that are being crushed into these structures. But if you look at them, if you look at this slide, it looks surprisingly like our aluminium foil, with some individual ones, but a lot of paired ones. And I think this is on, what is it saying? Figure 3. Let me find figure 3. Anyway, you can go and look at this in your own time. It could be figure 3. In zone C, there were also many ring spots, as shown in figure 3. The ring spots were smaller than in zone B, and I think this is on, it's on a metal plate that's recorded as far as I understand, but you can check on that. I might be wrong. Anyway, so here you have a steel bar where material inside it has been eaten away, largely in spheres, and John has taken a saw, bandsaw, or something similar, and cut this in half. And I'm not even showing it to you. So yeah, the spheres are taken out and removed from the material, and then he's cut it in half to find these things inside. So Takaaki Matsumoto, seeing it in 1990, he's verifying the observation, in my opinion, of John Hutchison in the early 1980s, probably as early as 1979. Then we have seen this. So the difference is that Takaaki Matsumoto is doing this experiment in water. Okay? This experiment is at room temperature. You can imagine that the water is also at room temperature, but as you know, if you do electrolysis and you've got a lot of current in there, then sometimes that warms up. But these things are well within the sort of boiling, water not boiling temperature range. Okay? And in John's, typically whatever the ambient temperature was. In the case of the next one, which I shared first at my Seek and Share presentation at Sochi, this is from a diamond. And so in this section here, you see a little bit of diamond that's not been damaged. And this whole area here has been really absolutely destroyed by whatever's going on. And a spherical structure has been taken out, and under SEM typically you'll find that these are secondary electrons, but you'll find that you actually get an idea of what the elements were in there in terms of their relative element masses by the whiteness or blackness of them. So we know that this is predominantly carbon, and so one might suggest that this is a heavier element. So did something eat something out of here and spit out a heavier element? Yes, Mark, it's cutting through diamond. It's cutting through diamond, just like this cut through steel and this cut through stainless steel. This is my point. So and these things can eat these materials for breakfast, you know, and it's not just that they eat them, is that they, it would appear, can compress them in and produce a heavier element out of their posterior, let's put it that way. I have to quickly put on some power, otherwise I'm going to lose my machine here. So what am I going to do? This could go all horribly wrong. It's going to complain. Okay. Oh no. Okay. I will get some better hubs. Okay. Disaster averted. Okay. Make a huge diamond and carve a sculpture out of it. Yeah. Well, it makes diamonds, but tends to be little ones. Okay, so so this is in the experiment of Lion, in the diamond in the core. And the interesting thing is here, in this case, the core we've established got to 1050 degrees centigrade. Now, diamond, depending on the atmosphere and depending on the chemical environment, diamond itself in a vacuum is the highest melting point element, and I think it basically sublimes. But depending on the environment, that can change. Obviously, we have nickel in here, and we also had deuterium, and so there is some potential interactions going on there. But I believe the interaction that's of import is that a coherent matter structure was formed, and it ate that for breakfast, and it spat out something of a different element. Now this should have Magic Sound Lab MFMP analysis on it, but what we are looking at here is the aluminum oxide, alumina core, alumina liner outside of the main core, which was silicon carbide of the Parkhomov 225-day reactor. And you have a sphere removed here, and you're seeing part of it. And if we zoom in, you'll see that there are other spheres of a heavier element, okay? And there seems to be like a chain of them. And the chain of these spheres are tending towards a point down here where there is like almost like a slug trail. And there's a little bit down here, and there's another little blob down here, okay? Now let's go back to the previous one. It's kind of coming out, and we have this little trail here with these little bits here, but it's kind of like going down to a point, and there's a lot of deposition here. This looks like almost it's broken off of here. But anyway, there's a lot of deposition, and it sort of fades away. Are we seeing the same thing here? Was one of these coherent matter structures in here? Now, we know from the work of Ken Shoulders that exotic vacuum objects, which you can think of them as an analog of ball lightning, and I think we've been able to demonstrate that they have a coherent matter body. He has taken photographs, even in his 1986 book EV: A Tale of Discovery, where they bore through alumina, that is aluminium oxide. That is what you are looking at here, and they effortlessly bore through it. And so is that what we're seeing here? And has the material then been transmuted into this? Well, what is that material? That material is this. So we had a look at it like here, and I've got an area and a spot sample here. The area sample kind of impinges upon the alumina here. And so there will be some contamination in the data there of whatever this ceramic was. So if you look at the point sample, which I think is the more accurate of them, it is 679, okay? And 679 is 50% iron atomic concentration. So if this was by mass, by weight, this would actually be quite a lot higher, okay? So it's got 19% carbon in that structure, and oxygen. So these are the elements. So magnesium is basically double carbon. Oxygen, if you had nitrogen in there and you fused it, you would end up with, if you do double nitrogen, you end up with silicon. So it's 214s go to 28, and so on. But these are the typical elements you will see synthesized out of this kind of technology when you're starting from light elements. Notice when we saw the heart-shaped structure, which is it's a slightly modified figure of 8. It was in the Claytor 2019 paper. He was, even though he had palladium with a 2% of silver in deuterium, he was synthesizing thallium, which is one stop short of lead, and thorium. Thorium. That is really, really heavy. Bear that in mind when I come on to part 2 of this series of videos, because I will show you something that's really quite amazing. But thorium is 4 times as abundant in the crust as tungsten. Hold that in mind. I believe that the crustal abundance is our guide. Okay, so where have we seen iron-rich spheres? Well, we showed a long time ago that in the Nova Basic, which is basically a chamber with a modified magnetron in there, and using charcoal, we created crenellated maghemite or magnetite spheres, which bunch together. They were not only able to be captured by a magnet, they also connected themselves to each other. I showed that the Hessdalen ball lightning area in Norway, there was an Italian study, and they did some soil samples where a ball lightning was meant to have hit the ground, and they found crenellated iron-rich spheres, and we're going to look at that briefly in a minute. Then in crop circles, apparently, in real worms, on the ears of corn, you find highly magnetic spheres on the tufts of the wheat. In the Tunguska event in 1908, they found nickel-rich magnetite spheres found inside the trees. I didn't even finish writing that. This is how raw this presentation is. In line 2, on the outside of the quartz, the first ball is half in, and then the subsequent balls are after it. It's in the silicon dioxide. Me356 saw clear polar pinch observable, and in the Parkhomov 225-day reactor, which produced over 4.3 gigajoules, that might be 4.2 actually, by the way, and over 2 mega electron volts per nickel atom. Okay, so I'm going to show you now, if I switch frames here, I'm going to dig up the presentation, which is a blog that I did on Steemit many moons ago, and we are good to go on that now. So this is it. It's called UFOs over Hessdalen, Norway Explained, Ball Lightning and Low Energy Nuclear Reaction. So you can go and look at that if you're bored. 10th of January 2019. Okay, so basically I looked at this. This is one of the more interesting findings. And you're probably able to now understand what happens here. So what happened, it collided and broke up the ball lightning, but it might just be separating its evil twin from its white twin. And as you saw in the Vega experiments, they can spin round each other, but one presents itself very different to the eye of the other one. And if you look at the Bogdanovich plasma flow discharge experiments, you can have a torus that is white and you can have a torus that is black. And even if there's a plasma discharge behind the torus that is black, then you can't see through that plasma discharge through the torus. It's completely doing something with that light and stopping it from going forward. So if you can imagine an evil twin spinning around a white hole, then you could develop a trace that looks like this. And there is other traces from Hessdalen ball light. So we've got literally a 1-for-1 correlation between what we've seen in the Vega experiments, what we see in strange radiation traces, which I believe is the same structures that we see in the Vega experiments, but in neutral mode, and getting excited when they go into materials and eating them in the same way that I've demonstrated for static ones in the previous number of slides. And what they can do is they can collect all this matter. And if you recall, when I was showing you in the previous presentation that when the Wardenclyffe Tower, I believe, was designed to generate energy, and I said that what I think you would get out of that is little iron, or probably magnetite spheres dropping out as it fused material in that process. So you get 2 nitrogens from the air, which is 78% of air. They go to 1 hydrogen and 127 aluminium. 227 aluminiums fused, and that makes iron 54. And there's variations around there. But it doesn't quite work like that. When we get on to talk about, according to Matsumoto, it really completely denatures the atoms when you get to the level of unifying all the forces, as Solin would have said in his 92 patent. Okay, so here we have Graham Hubler, who formerly ran the Naval Research Laboratory, and in 2000 was very, very interested in everything to do with ball lightning. He ended up running Skinner, which I found very interesting. I actually saw this presentation in University of Missouri. So yeah, the guy that was very interested about ball lightning when he was leading a team at the Naval Research Laboratory ended up running the cold fusion research many moons later. I wonder what the coincidence of that is. Anyway, okay, so iron-rich spheres. There we go. So these are the crenellated iron-rich spheres that were observed in a supposed ball lightning impact area by an Italian research team in Hessdalen. Okay? And here we have my slide, which I shared at Sochi. And this is an Ode slide. And you have this material here from a supposed crop circle with these magnetic particles. And you can see them all joining up on their pole. Here, this is on the outside of Lion 2's quartz. And the first sphere, as I said, is half embedded in the quartz. It didn't crack the quartz. It just appeared there in space-time. And so you can imagine that if you had a structure, and I've explained this to John, if you have a structure, and we've already observed both in the Lion reactor and in John's fracture sample, the entire surface can get skinned with exotic vacuum objects. And we've already shown in the Vega experiments that they can basically eat anything. I'm showing you here that they can make voids in things. Now imagine you have something that becomes neutral, and then it goes into a material, and then it basically gets a little bit excited. Well, it literally replaces the atoms. As the coherent matter interacts, it just eats the whole thing, and it makes the space it needs to be in. And so it literally replaces it. And it's a little bit bizarre to think about it, but we have all of the evidence to show that this is what happens. And so if you want this technology to teleport, hopefully you don't end up teleporting into the middle of a mountain and you're just basically in there. That just would not be fun. Okay. Here's the crenellated spheres from which I've showed you before in a more recent presentation in the Nova Basic. And so that's that. And then a note there about the Tunguska event. And so, yeah, here's a close-up on those. You can see the crenellations here, okay? Now, we go on, and you can see the usual elements here. So the red one is, if I look at the, okay, so look at spectrum 2 here. Spectrum 2 is oxygen 31.1 and iron 51.5 by weight. And because they're highly magnetic, they're either maghemite or magnetite. And this is from Me 356. Again, he's doing Lehner experiments, and he ended up... Oh, you can't see it. I'm very sorry. Sorry. I've got to find a way. Yeah, sorry. It's tedious for you, God. Okay, so let's go back. This is the first one. This is from supposedly collected from an impact area of a ball lightning by an Italian research team in Hessdalen. You can very clearly see the crenellated structure here. Okay. Now you can see the crop circle. Now crop circles are meant to be produced by a similar technology to this, and real ones, not people with boards walking around in circles on a string. Anyway, so you can see the highly magnetic particles here. And here you can see on the outside of the quartz, there's highly magnetic particles, almost like for like here. But the first one is 50% in the quartz. And what I was saying is like the material that came in the Parkhomov 225-day reactor, and I have actually much better examples to show you. I just didn't have time to put them in, but they like literally appear half in the material and half out the material, but they don't just like that steel was, or that wood in Hutchison samples was able to appear in the wood, but it didn't displace the wood. The wood just basically replaced in space-time the material. You can imagine how this works. Anyway, so here's the crenellated spheres from the NOVA experiment, and I've got a close-up here of that, so you can really see the crenellations here. I actually got this in a slightly better quality here. It's just JPEG'd by Steemit here, unfortunately. So you can see the crenellations, and they are magnetically binding themselves. There's a pole running along here, and you can see all the little ones are joining up over here, and these are merging together and all down here. So there's one big pole running through here. Okay, and you can see here that it's predominantly oxygen and iron, and so maghemite or magnetite are most likely the products. And this is from Me 356, and what I like about this crenellated sphere is two things. One is it's absolutely beautifully spherical. I mean, it really is beautifully spherical, but you've got the crenellations. It actually looks like someone's got a brain and squeezed it inside a ping pong ball. But look what's happening. You've got a pinch up to here, a pinch up to here, pinch up to here, pinch up to here. And so we have literally a pinching going on, and I would believe that there is a pole here, and I think there's probably a pole at the other end. If you could rotate this round, I imagine the pinching would be going down there as well. And I would imagine that these are the magnetic domains in this magnetite, as I expect it is, would be very, very well aligned. Let's put it like that. And we've already shown that the coherent matter technologically produced balls of fire in the Vega experiments. When one cuts at what I believe is the coherent matter skin, either on the inside or the outside on the tungsten wire, and it falls down in Henk's experiment, and it span round and it pointed to the other ball of fire that was on the end, shifting that entire piece of one of the heaviest metals there is in 3D space so that it could align, and it didn't come off. It was still attached to the metal. It likes to be in the metal more than it does coming off and being free floating. So that's all worth considering. Okay, so and this is John Hutchison's schematic for how to technologically produce ball lightning, and you know, he would shoot these ball lightning structures out of here. So there we go. Okay. Let me go back to the main presentation. Did everyone get that? Did everyone get that? Sorry about me talking to myself. Okay, I think at this time it's probably good to show the model of Takaaki Matsumoto's process. So here we have it. Okay, so this is Takaaki Matsumoto electronuclear collapse, and what I'm going to do is I'm going to read the section from his book. It's one of several sections that explains it, but I think this is as good as any. Okay. Essentially, what he's doing is he's invoking some subquanta of nuclei. It almost doesn't matter what they are. He happens to call them a mission and a celeron. In order to comprehensively understand all of electronuclear reaction phenomena, the NATO model has been expanded to deal with extremely small domain of 10 to the minus 33 cm. Is that Compton? Here we introduce a new hypothetical theory for subnuclear domain. The theory could be based on an important hint which was already obtained. It is electronuclear regeneration, which should require new components of at least two different kinds. Because only one component should fail to explain the regeneration of destroyed materials. Now, we introduce two super elementary particles called the meson and celeron. The meson is a tiny particle which is distributed in celeron and takes a role of particle-like behaviors for the conventional particles, such as electrons and nucleons. Meson might be a promising candidate for dark matter, which is expected by many astrophysicists to exist in the universe. On the other hand, celeron, which widely and quickly distributes in free space like thin films, takes the role of wave-like behaviors for the conventional particles. By comparing the two tiny particles, the dual property of the elementary particles, such as electrons and nucleons, could be easily explained. Okay, it almost doesn't matter if you take on board this, it's his idea, but roughly what he says he observed and the things that come out are quite in line with some of the things that I can demonstrate, and hopefully we'll get to that. For example, let us briefly consider a case of that an electron is put in a vacuum and driven by an electric potential. The electron could be assumed a combination of a lot of mesons and celerons, although there could be a lot of structural strata between an electron and or nucleon and the super elementary particles. We now have no information about them at all. The celerons expand in the vacuum with the velocity of light and fully occupy the vacuum. Here, the celerons could be confused with ether, which was very early proposed to explain the propagation of light. Celerons are perfectly different concepts from ether, because the celerons are of constituents of matter, while the ether is independent from matter. The NATO model proposes that the initial state of the vacuum is assumed to be perfectly empty. Here, electromagnetic waves could be explained as the vibrational motion of expanding celerons. Okay, anyway, now we get to the meat part. On the other hand, no, not quite. On the other hand, mesons are concentrated in a small region of the dimension of the de Broglie's length and pulled by the electrical potential. The distribution of mesons could be presented by the density function of the electron on the conventional quantum physics. Since mesons and celerons are connected to each other with an unknown force, the moving mesons could feel some frictional force and not fly beyond the celerons. This is a physical reason why the electron increases the effective mass during flying with a high velocity close to that of light. Right, here we go. During electronuclear collapse, the nuclei are completely destroyed, in which an individual nucleus is also divided into a lot of mesons and celerons. The mesons and celerons could hardly maintain their structures during passing through the wormhole. When they are emitted from the white hole, some mechanisms of their combination could work to form some particles of an upper class. After such processes are repeated, the conventional particles such as electrons and nucleons could be eventually regenerated. Here, it would be reasonable to consider that the destroyed materials quickly rotate in a wormhole and that regenerated elements are separated by centrifugal effects. Heavy elements such as iron and the light ones such as carbon and oxygen could be formed in the central and peripheral regions of the thin carbon tubes respectively. Iron in the center, carbon or oxygen on the outside. Bear this in mind if I can get to it tonight, the data from the Amazagás exposed 10 yen coin. On the other hand, no such effects could be expected during the explosion of a black hole, so the distribution of regenerated elements becomes uniform on the thin carbon films. The conceptual view of electronuclear regeneration is shown in figure 2. So that is the figure that I am showing you here. Okay, did everyone get that? Has everyone gone to sleep? Okay, so what you're seeing here is material is gone into an electronuclear collapse. It goes down to a point, and then there is, in this case, there's an explosion, or they travel through a wormhole And they come up spinning, 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 spinning. And on the outside, you get lighter elements, typically hydrogen, which you don't really see, but we do in Piantelli, and that's the whole basis of his technology. And you then get carbon and oxygen beyond that. I've explained why you don't get things typically observed lower than that. But you do, but not typically. And then in the center here, you've got titanium and iron and so forth. And these are common transmuted products. Okay. Right. And now I need to see where I am in my presentation so that I don't make a mess of it all. Okay. I know what I did there. And I deleted that slide, didn't I? Did I? I did. Okay. All right. Okay. All right. I'll do the next 3 slides. So, okay. So, online, we observed self-similar structures like galaxies. We had a 2-level one here, and you can see this ring with the spot, and then there's something pulling stuff in here, and something pulling stuff in here, or throwing it out. One of the two. But something has happened here and here. This is 3, and again, this is more like the 3-level wing structure that we saw in the vibrator system, the Ultra experiment. We also had the north and the south pole here, the north and the south and the north and south on the line material as well, and it ejected materials from point A to point B. And so these are polar structures which are a great distance apart rather than ones that have formed a cluster here. Now we also had this structure where we observed a 4-point structure here, and we have a 5-point structure here. Okay, and I'll zoom into that in a second. The other structure I want to show you is this paisley. It's like a disc with a tail, and this is the same kind of structure. This is eaten out of the material, by the way. This is the same kind of structure as was observed by Bogdanovich when he, after plasma flow discharge, he observed these toroidal-like structures moving around on the metal plate 2 days after the experiment had ended, glowing and so forth. But this is material, and the paisley, I've said since I think I presented this, it's a very, very important structure, and we're going to see why in a little while. So the next slide I want to show you is this, which is a very blurry blow up of that same structure. And now it's going to get really messy because I have to you have your yin yang here, your yin yang here, there's a yin yang here, so you have your overall structure, and then it has substructures around it. And you remember I pointed out in the hexagon with the 320-degree segments in the collapsing bubble in the Ultra experiment pit, that there was a white spot and then there was a black spot. Well, I believe there's a white spot, a black spot, a white spot, a black spot, all the way around. Anyway, we can come to that in a minute. I now need to, it's going to get messy, I need to go and get the data for the structure that was observed on the 10 yen coin, if I can. Wish me luck. Where is that? And this was all done at Alan Goldwater's Magic Sound Lab. So huge props to him for making this all possible. Now, I would have loved to have done beautiful GIF animations of this to make this really easy to comprehend, and the spatial locations. But I think what we have here is is good enough to get the message today. Before we go there, I'm going to pull up some better quality images of that. This one. Okay. I was going to see if I can find it on the directory, and I can just quickly run through things. So it's in here. I will look at your questions in a little while, so let me know when you're close to having some questions. Okay, so first off, if you've seen the beginning of the end video, that was all recorded live as we invented experiments on the fly and did them in the in fact, the time that you see in that video is essentially basically all of the time that we had to test a Mars gas. And you get to see every moment of it, including some heated discussions, which people have all kinds of opinions about. But anyway, what I've got here for you is a yin and a yang. I was always confused about this structure because it didn't go all the way through, and how did it happen? But now I've seen so many structures which don't go all the way through and they can cut a hole. That's fine. This is more deformed because it actually got pressed against the PTFE. But what initially got me was how hard this cut edge was around here, how hard it was. And you can even see here, it's almost like someone's got some masking tape and put a very, very hard line around this area here. So that always confused me. And the other thing is that this has all kinds of carbon over it, like a carbon film. This is the carbon film, I believe, that is being discussed by Takaaki Matsumoto. And you'll see this, hopefully, on the SEMs when I can find it. But I kind of just, for giggles, and the other word, I have overlaid this. And I can change its luminosity. So you can imagine that you have your pit on this side and your peak here. But the peak still does some damage. You can see that it's actually covered it with black or whatever. Is this a carbon film? I don't know. But this is from the ultra experiment that we did the other day. And so I'm saying that this eats the material out. And this shape here is almost like induction. You know, if you have a what do you call it? Yeah, basic induction. So there's definitely a strong magnetic field going on, I believe. Obviously, the copper is it paramagnetic, and the zinc in here is diamagnetic. I might have got that wrong, but anyway. So I'm suggesting that there might be something going on that is akin to this there. And I've got another one over there, and I can change that also to darken. So I'm saying that the hole over here was eaten by this side, but didn't make it all the way through. But this one did, and you can see it. And essentially, what you're doing in this experiment is exactly what we saw at the beginning. You're pumping it and pumping it with exotic vacuum objects that are forming on the fly, from the Amasa gas, and they can't go anywhere, and they're trying to self-organize. They're all reaching an equilibrium temperature. Copper's beautiful for this because copper is very, very conductive thermally. And so it's an even temperature here. You're feeding stuff in, it's creating a plasmoid, but the thing is self-organizing, and at some point it becomes a coherent body, and the evil twin just does what you saw on that video at the beginning. And I almost don't care on that ultrasonic video whether you consider it's combusting in the air, the chemical, or whether there's genuinely an effect that's similar to what we're talking about with everything else. It almost doesn't matter. It's actually an analog where you can watch the process happening with the twins, the yin and the yang. Okay, so I'm gonna pull up some more data here, but in the past, we have looked at this area quite extensively, and this has scallops out of it, and we have this beautiful ring here. I don't know if you can see it. If we go in, you'll recognize it maybe. But what we're going to do this time is we're going to actually look at a couple of things in this kind of area over here. This is our perfect kind of like ring structure. Okay, so just let me get those things for you. Okay. Okay, so just reiterate. Actually, I need to give you an establishing shot. So let me find that establishing shot because it's just not fair to not see it. So there's a whole bunch of stuff here. I like this one particularly in this zone. So you can see these carbon film areas are on the copper. And now, are these diamond? I don't know, but we have some examples that look exactly like the carbon film on the exploding indium foil that was as thick as a human hair, but was quite good at resisting the Amasa gas, which was slightly bizarre since it's the lowest melting point metal that doesn't react with water strongly. But yeah, so you see this ball with this gap around it. So that's one which is rather nice from this area. Let me see if I can find the structure I'm talking about here. Not there. Well, we're going to be looking at, where is it? Give me a second. Told you it was going to be messy. I wasn't lying. Okay, I think of the images, this is the best establishing shot. It's not great, but you can get the idea. I thought I had a better overview shot though. Okay, anyway, we have this for now. So the structure we're going to look at is this one. There's these rather nice features up here that we might get to. These little spheres, little pair there and so forth, but we might get to that. But this is the structure, and you can see it's kind of like a hexagonal structure here. And from experience, I can tell you that when you've seen enough of these, this is this carbon film that he's talking about. And I have a number of images here. So this is one way of looking at it in the microscope, and you can see there's something going on that's different in the middle, and you have this hexagon type shape on the outside, and on this one it's a little bit different, but just a different way of looking at it. Now I'm going to show you the SEM data here, and we actually have a map, and as I need to say again, this was done by Alan Goldwater. He's a volunteer with the Martin Fleischmann Memorial Project, but this is in his Magic Sound lab, and we thank him for doing this. So here's an overall map, but it's when you get to look at the these particular element maps that it really sticks out. So a 10 yen coin is mostly copper with a bit of zinc and a very little bit of tin. And the tin's basically not showing up. When you see something that's very spotty and it's everywhere, it's almost not there. And it's like 1 to 2% is tin. Quite a bit is zinc, but most of it is copper. The interesting thing is, in the structure that you've just seen, is basically not showing any copper whatsoever. So the copper's like gone. And this is similar to that bowl-shaped structure with the ring around it. The copper had gone in that. And then in this one, we've got a little bit more zinc going on, but predominantly the zinc is on the outside. But here, the carbon is here around the outside. So let me go back to the presentation. What did it say in the presentation? What did he say? He said the carbon and the oxygen is on the outside, and then you get the heavier elements in the middle. So we've got our carbon on the outside. We have the oxygen on the outside. Okay. Now we have also sodium on the outside. So these are the lighter elements. But now look what we're having here. Aluminium is in this 5-pointed star in the center. I showed you a 5-pointed star on the Lion reactor. In fact, I showed you a 2-pointed. I showed you a 3, a 4, and this is a 5. So there's the 5, and you've got your yin-yang, your yin-yang, your yin-yang going around. These are Paisleys in action. And in fact, what's happening here is that this is supposedly copper oxide, but the light is going onto this copper oxide, and at these points, it's registering as a different element. And in fact, it's not actually registering as any element that exists. Something happens to the photons that are coming back from the electron incident beam, such that you can only guess an element, and then I've applied a color to that guessed element because it doesn't match any of the real elements in the periodic table. And then I've shown it on here. Now I called this tractor beam or something, where I'm saying is it's actually able to slow down or speed up light. And so this image is actually made by the fact that something is going on that's very, very weird. And in fact, if you look at the presentation where I do this, depending on the instant angle, you get different elements reported. But there could be an artifact with the scanning electron microscope, but that's not the case in this case. So here you can see aluminium and silicon. Now, aluminium and silicon often appear as a pair. This occurred in the Hutchison sample. But you can see in the center of the center, and with a little ball right in the center, we've got calcium. So the heaviest element here is not iron. So this isn't as aggressive as we saw in the Hutchison, which was done at room temperature. But this is done at whatever temperature the Amarza gas initiated on the copper. And I think in tungsten it was like, 700 degrees before it started doing something crazy. I think in titanium it was like 230 or something. It was never above like 1,000 degrees. But anyway, these are much more above room temperature, but they're below the temperature of what's occurring in the Lion reactor. So this is why I'm saying coherent nuclear transmutation. Coherent, it's not important the temperature. You just need all of the matter to be at the same temperature and in phase, And if you get enough of it, pumping and pumping and pumping it, it goes, loses all identity of what elements and atoms it is. And then it, according to Matsumoto, it comes through a little wormhole and comes spraying up. But what we can definitely see is that you get these features. And this is not the only one that you're going to see showing these kind of patterns. But this is textbook what he was saying. The carbon is on the outside. The oxygen is on the outside. There's a little bit here, but that might have been a later oxide of the calcium here. And then you have the carbon here on the outside. The copper's outside the overall structure. So we have the overall structure here, and the copper and the zinc is on the outside. The hexagonal structure, and this is bizarre because it's like a hexagon, but inside it's a pentagon. Whatever. Yeah, so we got the carbon and so copper and zinc on the outside, tin as well. Next one in is in the actual structure, which is the carbon and the oxygen and the sodium. And then in the core of the core, you've got aluminium, silicon, and in the core of the core of the core, you've got calcium. I think this is very, very, very close to what was being suggested by Matsumoto. Okay. So I have another slide that I've got to finish building. It's just very silly. Okay. Now give me a second here. I've got to find the data and then put it in there because I'm building to something here. I need to go. Where do I need to go? I need to go. Hold on. Damn it. Okay. All right, I'm just going to go and show you this slide because it's actually on the drive that I've unplugged to put the power in. But give me a sec. Bob's worst presentation ever. Okay. All right. So this is from the line. You can get the actual high resolution images. I haven't got the zoomed in image. I've just zoomed it in here. But there's the overall scale. This is a big structure, but I have this in much, much higher resolution. But when you come down, you have these pairs at a much, much smaller quanta level. So it's self-similar. And this is what I was describing earlier. You have the focal point where you get the intensity, but they're like one charge and another charge. And it's smaller versions of the same charge that collate to make a much bigger version of that charge. And you know, I would think I was being original, except it's all in the Solin patent. So, you know, I'm not even being original. Okay, so with that, I'm going to dig up the data from the Ultra experiment, because it was stunning to me, and I hope you enjoy seeing this as much as I did. Okay. Right. So we don't want that anymore. This is even more raw because the documents are in a format that doesn't actually look so good until I process it. But I was keen to just get this to you today in its raw form, because there's quite a few out there that are actually doing Ultra experiments, and for me this is just, it's totally inspirational that this is now in this kind of level of reality. So let me, where is it? Okay. I'll just re-download it, hopefully. So thank you again, Alan, for taking the time to actually do this today, or yesterday. Really means a lot to me. And hopefully everyone else will appreciate it. Let's hope this works. So I'm having to use LibreOffice here because the output from the software doesn't, even though it produces a docx file, it doesn't actually work in Office. It just mangles everything. So I have to put it through this first. Anyway, this will be good enough. It's very, very raw. It's like you're in the lab with me and you're seeing the first time that we're looking at this. So thank you very much, Alan, at Magic Sound. So this material that you're seeing in the background here is the carbon tape, and this is something that you stick your samples on. So this is the first sample. So basically he ran an experiment very similar to the one that I've showed you, no complications, and used the magnet wrapped in something to collect a few magnetic particles, and this is what he found. So we have something that is aluminium. That's not surprising. This is more interesting because it's like a long stretch structure, and it's more interesting because of what it's made of. It's iron and nickel, but it has a bit of chrome in there. So there's a chance that this could be steel from the container. That is a possibility. So you've got iron. Fluorine is often... No, sorry, that's potassium. So it's interesting that you've got potassium in there. I don't know why that would be there. And you've got cobalt in there. That's interesting. And chromium and nickel. So it could be steel, or is this the core of the wormhole coming out as per the Matsumoto model? Don't know. It does look a little bit twisted, so maybe, who can say? And anyway, so I think Alan got a little bit excited with this bit, so he had a look with some sample areas here. So they're ranging from 2107, I think, or something like that, all the way to 21117. So he's got them here, and they have varying iron, and if the iron is low, you get much more, where is it? Oxygen, it would appear, and so forth. But here's where it starts to get really interesting. Some spheres. Some spheres. Now remember what I told you the other day? I got this propeller-shaped thing which had a hexagon in the middle, and in the center of the center it looked like it had a sphere or something. And I speculated whether that could be a magnetite or iron sphere, and I would love to see it under an SEM because that's what I believed it would be. Well, this is what he sent through. Okay? So you've got it here. Now, I haven't done a contrast adjust on this, but can you see what you see on the surface here? Does this look crenellated to you? Does to me. It's not very clear, but we actually have an image, and I'm going to live process it on this stream. So we have not a massive amount of iron, okay, and it's got plenty of carbon. So this does look like something that could come out of this, and we have oxygen. So carbon, oxygen, magnesium is 2 carbon, silicon is 2 nitrogen or whatever, and you can get there via other paths, and some iron. Now here we go. He's come in and he's doing some spot samples on it, and definitely you can see that this is now crenellated. Okay. And what is he seeing in those spot samples? Well, on atomic concentration, so this would be bigger if it was mass, he's seeing carbon, oxygen. These are things that you would expect out of this system. Obviously, you've got oxygen in the water, in the air, and so forth, but you've got iron in quite a large amount of abundance, up to 29% here. And so you can imagine that with this and this oxygen level, you could have some phases of magnetite on the other one, which I can't say so quick easily, in here. So there we go. We have some potential magnetite spheres. And here is an even more beautiful one. I'm not going to give it the Me 356 most beautiful Lena magnetite sphere, but it's bordering on it. It even looks like a moon, doesn't it? It's like our own moon. Is that a pinching on the top there? Could it be a pinching? I don't know. Well, let's see if we can do some contrast adjust. Oh, the other thing is, are we seeing a carbon film here? Is this a carbon film? I don't know. I don't know. Is it a carbon film? Let's see what it says. Oh, it does look green, doesn't it? Okay, look at that. I mean, it's literally, it looks like our own little blue planet. How wonderful. Oh, there's a pretzel down there. You didn't spot that. it's out of view. Anyway, so let's see what this sphere is made of. Well, it's not carbon. What you're seeing on here is a Fresnel effect. So the electron beam from the microscope is hitting here. It's bouncing off the carbon tape, and it's reflecting the photons back in a Fresnel type effect. So this glow around the outside, and this is something that you must be very careful of when you've got some sort of topology in your SEM, and you've got a curve. You can actually see, like if you're on an aluminium stand, you can actually see aluminium when it's not there. Or if you're on carbon, you can see carbon when it's not there. So it's the center here that's most interesting because it's still being lit by the electrons. And what do we see? Well, we see oxygen, definitely oxygen, right? And what do we see? Not a lot of magnesium. There's as much magnesium here as there is in the general area. So I would discount that. Again, the silicon's just about as much as it is in the background, so I would discount that. But what do we see down here? Iron. Iron. It's a blue sphere. It's blue. There's so much iron that nothing else appears in the SEM's image. There's no iron whatsoever. So this tells you, this image here tells you that there isn't any silicon worth talking about, not a lot of magnesium worth talking about. And on here, there's no carbon, essentially. It is basically iron and oxygen. It is a crenellated magnetite sphere, or mehematite, whatever the other one is. So there we go. I believe Tesla's energy generator would have produced a lot of magnetite spheres. Here's some other random pieces. What have we got here? This is yeah, it's mostly iron again. This is interesting. It's a linear structure. This looks like a rolled up film of something. And if you look to see what it is, what is it? It's carbon. I believe this is the carbon film that Matsumoto is referring to. And you will see this there's almost an image that we have from the Amasa gas on the indium foil. And the carbon film section of that is almost the exact replica of the drawing in Matsumoto's paper. But anyway, so yeah, you can see the carbon there and oxygen, but there's not a lot of anything else. Okay, and I think there's one last one of interest down here. It's this flake, and the flake itself appears to have a sort of crenellated surface to it. And I wonder if this isn't a section of a larger sphere. It is quite large. This is 40 micron. But it is, you can see the elements there, lots of iron in there. But that's it. So I think the money shots for this are 4 experiments. 2 Daves sequentially produce magnetic particles. My one, which I didn't bother to do the experiment, it produced a magnetic particles. One which I went to in detail. It has a hexagonal structure. It has a trefoil kind of thing around the outside, 3 wings, and then it looked like it had a sphere in the center, which I suggested might be magnetite. And then Alan goes away 2 days ago, runs the experiment. First time he's getting magnetic particles, and in those magnetic particles he is finding crenellated magnetic spheres. I believe we have a technology here which can be done by 5-year-olds, and there may be other methods to test for the magnetic particles. I mean, you could put a lot of aluminium in there and maybe get a lot of material out. And you can demonstrate Lena any day of the week. Now, one thing I would like to see is for a container that is like pure nickel, or the oscillation chamber, the water container, or pure silicon dioxide, or something like that, so that we can remove any doubt whatsoever that the iron is being extracted somehow and made into a crenellated magnetite sphere from the iron that is in the container. But it is a stainless steel bowl, and there is no chrome and there is no nickel in those crenellated magnetite spheres. There is no chrome and there is no nickel. So it's a pretty fancy contamination to grab stainless steel from the container, wrap it into a ball, remove the chrome, remove the nickel, and make it into a magnetic lump. I think it's pretty impressive. I'll use Occam's razor here and say that it's the same thing that you see in the Hessdalen ball lights. It's the same thing that Me356 saw. It's the same thing that we saw in the Lion reactor. Same thing that we saw in the Parkhomov reactor. Same thing you see on crop circles. Same thing you see everywhere that this technology is used. And with that, I'm going to show you a couple of slides from O-Day. Is there any questions? For a controlled, perhaps dissolve some of the foil in acid and then test anything that remains. That's not a bad idea to do it, but I mean, it's more effort. Use an aluminium bottle. Very good. I mean, you want something stiff, Axel. Yeah, you want something stiff. They're not normal contaminations. Yes, so actually Alan did say that potentially the iron sphere could be something due to the rolling process. And that is possible. But you are right. So start with a load of aluminium, dissolve it away. You could probably dissolve it in a caustic solution. And then see if you've got any magnetic particles, and are those magnetic particles in the same structure here. But we're not just looking at one data set here. We're looking at a broad range of data sets here. And for instance, in the Parkhomov reactor, his iron-rich spheres, he doesn't have iron in the core. In fact, he doesn't have iron in the heater wire because he uses tungsten. The heater wire in his reactor is tungsten. So he doesn't have that. As far as I understand it, Me-356 was using nickel and titanium and hydrogen, so there's no iron there. In the our test with the Nova reactor, we were using charcoal. Now, you could argue that wood has a very small amount of iron in it, probably, but enough to make very large spheres. I don't know. I don't know whether that would be something that's reasonable to assume. I'm going to pull up the better images. I think he's got an image here we can actually look at reasonably. Oh no, it's not so high resolution even as the one in the shot there. Okay, that's a shame. Okay. Oh well, I think that's the best we got. So I'm going to have to ask him when he's got off his break to generate a few more of these maybe and have a little bit of a closer look. Okay, so well, you've got some questions before I do my O-Day slides. Batman, in terms of dealing with nuclear waste, if you didn't have anyone nearby and you could maintain the flow rate and so forth, it would be a hydrosonic pump is probably the fastest way with cavitator, but you have a risk of creating more radioactive waste than you started with. So I like Amaza's vibrator plates. They've already demonstrated that they can remove without producing anything toxic. They can stabilize the water to 2 half-lives lower. So that's like nearly quarter of a century, but in 1 month. And that actually, I need to correct what I said the other day. That test was done with Fukushima water with the knowledge of TEPCO and politicians in 2012. So that wasn't something that happened in 2011. So I need to correct that from what I said in the last video. So here's vibration technology. Now, in terms of the environment, I would use Hutchison scalar technology gently. And then in the case of the solid waste, I would use Amaza gas or Brown's gas. I know that Amaza gas is transmuting. I expect that when we get to test the Brown's gas generator, we will be able to do a similar thing. The beauty about Amaza gas is, unlike Brown's gas, Amaza gas is proven to be able to be stored at pressure for over a decade, 12 years I think now, and counting. And so you have a potential to have modular nuclear reactors that are fail-safe, and you could go and deal with anything that they have. You could have a little one in every town, and they fail safe, and they have such little material in there, but you could go in and you could turn it all into edible carbon in almost like a purge system, where you hit it with and I've explained you need, when you understand the technology, it makes sense exactly what Yul Brown used. You use aluminium shavings, you use bits of iron, and you use the gas with your radioactive material, and you could make this into a flow process. Yeah. So Fukushima for me is they have this ridiculous amount of money to try and fix it over between now and 2050. It won't be fixed with the approaches they're taking, in my opinion. And it'll just be like, is anyone looking? Right, we'll get rid of this. Is anyone looking? We'll get rid of this. And it'll just be that. Or we'll bury it. And people will forget about it. But the cancers will still occur. They just won't be able to be attributed. And that's what kind of upsets me about it. Yeah, the ultrasonics is effectively a longitudinal wave, and it would appear that it does the job. On that wing subject, I'm just going to show you something else on the microscope here. So before we go on to the last bit here, because I think this is absolutely beautiful what I'm going to show you here. Because there's another structure on here, and it's over here. And remember what I said, there's a trefoil. The trefoil that we looked at out of the experiment in the Ultra experiment. Here we have a trefoil on the ball burn sample from John Hutchison. If I rotate this round, I don't know if you can see, but each of those wings has two spots. The one that's least eaten away is in the lower part of the frame, and the lower part of the two spots in that frame has a hexagon around it. And is this indicating the actual structure of these things? Maybe, maybe not. I'm going to zoom in so you can get an even closer look at this beauty. Look at this beauty. So this, I believe, maybe, it could be, I don't know. This could be similar to what we observed in the vibrator experiment. Is it going to focus for me? I don't know. It's a little bit fuzzy. Sorry about that. Is it going to let me focus a bit better? Can you see that hexagon there? Is it just me, or is there a hexagon there? In that bottom one of the pair in that wing. So you've got two in each wing. The kind of one in the bottom's not so good as the ones in the top. And you have a sphere. The one that's mostly in the center of the frame. Let's get it into the center of the frame so you know what I'm talking about, because I can't actually wave anything on this. So the sphere in the center of the frame there, I believe, would be predominantly iron. So that's that. And so when you get that this is what it is, you will see this absolutely everywhere. It's that whole thing about when you learn a new word, it just appears everywhere. There we go. You can see that hexagon now? Can everyone see the hexagon? Okay. And so we got a spot there, and then over here we got one with a radius around it there, and one with a slightly larger radius around it there, with the black sphere in the middle. And it's not so clear on the other side, but this one actually is like a load of white stuff around it. But and there's two more ring stuff around that. When you've seen this on other types of material, it kind of like pops out to you, but it's less convincing in isolation. But no, let's just make that a little bit smaller so we can get the whole thing on frame. And I'll play with the specularity on this so you can see, because the specularity shows different things. So this, you can almost see the trefoil on the outside, and then there's a trefoil pointing to the creases in the center, kind of, if you work hard with your imagination. Anyway, and this is with the specularity totally full on. Okay, this sample's just frankly amazing, really. It's got everything you want. I mean, there's this effect of the balls eating into the material all over it, and there's plenty of the heart shapes as well. Slightly out of focus there. There's one of your heart shapes. I think I've got another one. Maybe, I don't know. It's probably a big one. These kind of looks like the examples in the Matsumoto text. There's a nice pair. Anyway, right, I'll get on with the other slides now. So I will try and get as earliest opportunity, or anyone else that has the ability to do this, it would be great if you have the ability to get some samples onto an SEM. And I'm going to kill that one. My machine is getting so hot. Sorry. Okay, come on. I can almost draw my screen faster than this. I'm getting there. Bear with me. Ah. The dock is frozen. Okay. Okay, all right. I think we're almost in a position to do this. Oh no, come on. So this is slide 36 from Ode. It will be when it plays. Come on. I can literally draw it faster. Okay, all right. So, what you're looking at there on the left here, these are two meditation balls. It's got clochonne in there. It's like a brass kind of structure. And it has a yin-yang in there. So you have, if you can imagine it, material going into the hole here and going to feed the white hole, and then it comes round and vice versa. So they have a relationship between them. They are interconnected. And I've got the meaning down here of yin-yang. Positive, negative. Describe how seemingly opposite or contrary forces may actually be complementary, interconnected, and interdependent in the natural world, and how they may give rise to each other as they interrelate to one another. Okay? And I actually went to Beijing. I was fortunate enough 31 years ago. I was 18. And I chose to buy a pair of these in one of these exact type cases for every member of my family. I don't know why, I just like them and so on. So for me, this is a little bit of destiny. And on the right hand side here, can anyone guess what that is on the right hand side? Can you guess what this is on the right hand side? Anyone? Anyone guess what we're looking at on the right hand side? On the right hand side? No. What you are looking on that slide is what is claimed to be a glacial feature. 70 meters below ground in Manhattan. It was uncovered when they were clearing a site in the early 2000s. And what you see is a sweeping of material round to here, and then it gets to this point and it like immediately goes up. That's what I see. It sweeps round here and it immediately goes up. But what do you also see? Whoever took this image must have been absolutely fascinated. I'm going to play it right now. Now we know that the yin-yang doesn't really move. They stay static. But things spin around them. And they can churn material. And I believe that what you're seeing here is that at some point in the history of this part of Lower Manhattan, there was an extremely large plasmoid or exotic vacuum object, an extremely large one, that this is a substructure of. And at the speed of creation, this rock was liquefied and came round here, and it got to the event horizon for the mother structure that was much higher above it. It literally went boom and straight up. Anyway, that's a bit of fun for you. There's another picture of this you can find on the web, and it shows the yin-yang very, very much more clearly, but it's less front-on. I don't know whether it's actually of the same one or another part of this structure. But as a glacial structure that we are led to believe this is, I think it's amazing. So maybe in the last ice age, something happened in Lower Manhattan in the last ice age that caused this amazing structure, the Paisley structure and the yin-yang structure. And by the way, this circle here and the placement of the yin-yang is spot on for these old Chinese yin-yang prayer balls. It's like spooky. Anyway, so there's a bit of fun for you. What is the yin-yang? Well, the Paisley. The Paisley pattern is from Persia, and it's from the first monotheistic religion, the Zoroastrianism, and it's the symbol of life and eternity. It's the symbol of life and eternity. And if you look at this, a typical representation, you always have like even numbers around. It might just be the design, the art, and these little bubbles. This looks like the ring of bubbles around the central bubble that you saw in that collapsing bubble. But anyway, this Paisley pattern, we physically seen it in our reactors. In the Lion reactor, it was actually in the copper oxide as material removed. It is the shape that was in the structure that Bogdanovich showed. It's a kind of like a little Paisley. So it's a spinning thing with a little tail. But I believe that it's this material that spins around it, like you see in this glacial feature in Lower Manhattan, that I think is very, very interesting. They must have had a lot of weather back in glacial times, a lot of weather, you know, like snowstorms with big bolts of lightning. Anyway, and then you can see this actual image is a section of an image that was on the it is on our YouTube channel. Is it on our YouTube channel? Yeah, it's on our YouTube channel at the top, and it's the right hand side of it. It's been there since almost the day I took it in early 2018. And in here you have the Paisleys in the copper. It's not all the way through. This is more affected and this is less affected. But in one little zone, you have these Paisleys. This is meant to be pure copper. This is copper oxide on the outside, but it has Paisleys. Now, the reason I'm showing you this is because I'm going to share a image from from Matsumoto. Actually, it's a paper from Matsumoto. That is one of the new papers that I've received, so I'm just going to get that for you, and I'm going to read it through. And I mentioned it the other day, but he is not the first person to discover this. He thinks he was, but he wasn't. The Russians had done it before him, and probably Tesla before them. But I have it here, and he's the first person to have written about it and recognized it for exactly what it is. So this is number 60 from his anthology. And I will share it now. And I will probably make it a little bit bigger so you can actually read it, have a chance of reading it. Okay, nearly there. It's not very long, so don't worry. Okay. So, discovery of a new kind of electrical current. As I said, it's discovery for him, but the Russians had already got there. As it says in Tom Bearden's book, they had used a Tesla coil, and they used an 8-micron wire, and they were able to generate something with the Tesla coil and a spark gap that was able to travel down an 8-micron copper wire and then go into 25 kilowatts of light bulbs. And I've discussed this in the past. So, discovery of a new kind of electrical current. This is from Proceedings of ICCF 6 in Toya in 1996. Abstract. In previous experiments of underwater discharges, anomalous sparking was observed on a pinched region on the surface of thin wire electrodes such as nickel. The sparking was found to consist of tiny ball lightning, which had a ring structure about several tens of micrometers, and had decayed to a regular hexagonal plate. Everything we have seen in this presentation supports what he said in 1996. Why were not more scientists paying attention to Takaaki Matsumoto? This time, a new kind of electrical current, completely different from the conventional electric current, was discovered during similar experiments of underwater sparking discharges. The discharges were performed between thin wire electrodes of nickel, 0.1 to 0.3 moles per litre. I think he's got an electrolyte in there. The electrode on which sparking was attempted to appear on was a ball-like rolled thin wire of nickel, about 30 centimetres long. So he's got 30 centimetres long of this thin nickel wire and he's rolled it into a ball. When a pinched region was formed on the surface of the electrode over about 40 volts, sparking caused the ball lightning appeared associated with the drastic reductions of hydrogen gas evolution and the discharge current. A new kind of electrical current was observed as the flow of these tiny ball lightning by the element analysis with SEM-EDX of deposited materials on the surface of the thin copper wire. Sorry, it's bad translation and OCR at the moment. But by element analysis with SEM-EDX of deposited materials on the surface of the thin copper wire, which connected a discharge cell and an electric power supply, the transport of tiny ball lightning was proven. Materials, as well as electrical charges, were driven by the new current. The mechanism for the generation of the new current, as well as the tiny ball lightning, will be explained in the NATO model. Okay. So, I am saying, and bearing in mind, I only read that 3 days ago. I only read what I just wrote you there 3 days ago. But at the beginning of 2018, I saw these things. I recognized them as transport of materials, and I've had it as the image at the top of our site since then. And this was one of the early slides. It's quite early in O'Day's development. And so you have your yin yang spinning around in here. It transports material with it as it moves, and it's moving through the wire. And this is where it ended up. And actually, we know from the Lion reactor that he put silver foil on the end, and we found silver 2/3 the way up. So it travelled up through the copper wire, the silver. It was transported exactly as Matsumoto described at ICCF 6. The next slide from O-Day, which was one that I already shared at my Seek and Share presentation. So, these I should have had one other slide in between here, but it was the slide where we have all of the. Maybe I'll get that slide. Let me get that slide. There should be another slide in here. Sorry. Like I say, this is going to be a mess at places. I got one more slide to put in here, which should be there, because otherwise it doesn't make sense. Bear with me. The reason I'm doing presentations in this format, if people know, is because I literally have a lot of stuff to get out the door, and it takes a lot of effort to make a very short presentation, so. There's going to be people that hate the format, but what can I do? When I get data like I got, when I get data like the ultrasonic thing with the 2 spots and all the dynamics going on there, I had to study it and process it and get it out the door, and that took a day out of my time and thinking about that. And so and then Alan came through this morning, so I had to rejig what I was going to do, but I'm happy it did, and it's just fantastic. But I wanted you guys to know immediately, we have a lab rat, and it's a lab rat in my belief that is just, it's so trivial. It's so trivial. What am I looking for here? Oh, I know what I'm looking for now. Now, it is this new type of electrical current, which is not new. But anyway, he's the first person to have written it in a paper and presented it at a conference that blew up, in my opinion, Tesla's power station, in Chernetsky's power station, in Hutchison's power station. It is what caused the problems for Suhas Ralkar when we were with him with his equipment tripping out. So it's something that you have to try and avoid, but it's difficult to avoid. Okay, so this should have been in here, and it's from Seek and Share from my Sochi presentation, but it is originally an O-Day slide. Okay, I can get back in the room now. Okay, it's going to show it. So on the left here, you can see I've shown this. Like I say, this is slide 62 from Seek and Share, my 2018 presentation. So this is the Hutchison effect aluminium sample. And on the right, you see the skin of exotic vacuum objects with the yin and yangs arranging themselves, self-organizing all over the surface. And at the same scale and same magnification, you see it over and you can see the edge here and the edge here. This is the edge of the aluminium. This is the edge of the quartz on this jewel in the Lion reactor. And this from Lion 2. And this whole thing was skinned with these exotic vacuum objects, and this prevented the damage that occurred to the rest of the quartz. So basically, it's got the heater wire on the outside, it has the reactor in the center, and whatever happened to all of the rest of the material didn't happen to the bit that was covered in this coherent matter sheath. And so there you have it. So it did change. I mean, you get rose-colored quartz by exposing to X-rays or beta particles. So some X-rays and beta particles did get in here, but that might have been from the exotic vacuum objects that were on the actual sheath part, right? But the actual sheath prevented transport of material and appearance of material and exotic vacuum objects within the structure. So as Ken Shoulders said, the only thing you can use to protect yourself from an exotic vacuum object projectile is a skin of exotic vacuum objects, which is very difficult to do. And what you're doing is you're seeing it here. So this is a force shield that prevented this fused quartz from suffering the same demise as this. In the case of the Hutchison fracture sample, the yin-yangs are arranging themselves all over there. And I've done a very simple one on this one to show you, whatever it was, to show you a kind of much less magnified, smaller collection. So you can start to, there's a nice like vortex-like structure, but anyway, there's another one, but it was over here. This trefoil here, where you've just got three of these things coming together. You can start to see how they would all sort of intermesh, and then you would end up with what you are seeing here and here, this being at room temperature and this being at 1050 degrees centigrade. Temperature is not important. So then I will show you one more slide from O'Day, which is Seek and Share slide 63. The links that on here are to other slides in Seek and Share, but essentially these structures effectively form a mesh, and on the Temple of Osiris you have this supposedly laser cut into the wall, showing the flower of life, but this is basically what this structure is. And I have said that this structure, which I had the pleasure of touching when I was 18 in the Forbidden Palace, in the central pagoda in the Forbidden Palace in Beijing, this is the food dragon is based on the ancient Indian temples, and so it is my understanding that at every point, every major civilization had good knowledge of this technology at some point, and this is a model of the ball lightning structure. And you can see the fleur-de-lis in the center here, and the different levels of grouping, and the binding force both ways, and the sharing of material and so forth, and the hexagons here and so on. So I think this is a good representation as a starting point to think about the structure of ball lightning. And why am I very sure about that? Why am I sure about that? Yes, the next one should be on Sunday, Jason. Yes. I'm pretty sure about that, because it isn't just the Egyptians or the people that came before the Egyptians, and it's not just the ancient Indians or the ancient Chinese people that had a good working knowledge of this technology. It's also the Europeans. And I'm going to introduce you here to the thunder god Perun and similar. Okay? And this is Gromavoti Znachi, or thunder marks. These are thunder marks. Are considered by some scholars as ancient symbols of Perun, which are often engraved upon roof beams or over entries of village houses to protect them from lightning bolts. The circular shape symbolizes ball lightning. Their circular shape symbolizes ball lightning. Identical symbols were discovered on Slavic pottery of the 4th century in the Cherniakov culture. And what you are seeing here is a trefoil, or actually you could liken it to the 6 points that we are seeing in many places. Is this a yin? This is a yang. This is a yin. This is a yang. This is a yin. This is a yang. And they pull material in from the outside, and then they throw them in the center. But is the orientation this way, or is it this way? Is it like we see in, if I can find it, let me show. Is it? This is a 5 point. This is a 5 point. Yeah. This is a 3 point. This is like our trefoil, which we came out of our ultra experiment. This is a 2 point, and on here in this point we have a 4 point. So they can cluster together, but they focus material into a center point. This is either coming out of the material, or it's going into, because it's got a hole, and this is the reverse because it's got a lump. This is rotating this way, and this is rotating the opposite way. So this has got a lump and this has got a hole, or they're the opposite poles. But anyway, so going back to this. Now this is when you get a bit of a serendipity. I'm going to read this, and then I'm going to tell you what happened. So I first saw this structure on 23rd of February 2018. Within a few hours, I'd come across this. Equivalents in major religions. For example, Indra in Hinduism. He is the god of lightning, thunder, storms, rains and river flows. Indra is the most referred to deity in the Rig Veda. He is celebrated for his powers and the one who kills the great symbolic evil, Asura, named Vritra, who obstructs human prosperity and happiness. He who obstructs human prosperity and happiness. Indra destroys Vritra and his deceiving forces, and thereby brings rains and sunshine as the friend of mankind. So this god, represented by ball lightning, a symbol that's supposed to represent ball lightning, and is exactly the substructure of ball lightning. This is the same god that they have in the Hindu texts. I told you that the temple dragons come from India. Those temple dragons that have that superstructure of this, which we see here. This is the superstructure, which is in the Arabic culture. There isn't a place on planet Earth that doesn't have this. Now, I'll tell you something very, very spooky. I had just read this. I had just finished building this part of this slide on the 23rd of February 2018. And my former business partner, who I set up my first animation company with, he phoned me. He says, "What are you doing?" I said, I'm putting a slide together. I think I've worked out how low energy nuclear reactions works. And he says, I said, "What are you doing?" He says, "I'm working on a Hollywood movie." I said, "Awesome, man, fantastic." I said, "What is it? What is it?" He says, "Well, it's Chinese funded and it's called Asura." I'd never heard of Asura in my entire life, not once. And within a 2-hour period of discovering Asura, in the process of making this slide, he phones me up about a Chinese movie that he's working on, and it's called Asura. I don't even know whether it's released. But maybe it is. Maybe it's still in production. I don't know. But this was in February, 23rd of February 2018. So it's a little bit spooky. So the god of Preran, symbolized by this structure, which is the structure of ball lightning. And it was known all over the planet at some point in our species history, and does unimaginably amazing things and unimaginably terrible things. Unimaginably terrible things. But I had a choice to walk away from this technology in 2017, or make sure that people understand what it is and can see it for what it is. I've said for years, don't bother relying on anything that isn't at least 70 meters underground. The only way to protect knowledge is not to put it in the crypto chain or blockchain. You can't put it on a cloud drive. That's not going to protect it. In fact, if I wanted to make sure destruction of all knowledge, I'd convince the world's population that things were secure in the cloud or in cryptography. Because everything that's silicon will be completely vaporized if this technology was used in the way I believe it can be used. It will be turned to particles smaller than a human red blood cell, and you can literally wipe the planet clean, except for maybe some foundations of some megalithic structures. But anyway, what you would do if you wanted to protect this knowledge, and if you want to learn about the truth behind this knowledge, is you look at stone artifacts that were buried. And anyone that knew about this knowledge would have done that. They would have carved into stone and put a load of soil on top if they wanted the information to persist. So you might think that me asking people to capture the videos of what I'm sharing is useful. Well, that stops one level of destruction of this knowledge, of the burning of the books. But if you haven't got a hole that's 70 meters underground and something to read it with afterwards, your best bet is to carve it onto stone. Really, it's to carve it onto stone. So, I think I'm probably at the end of this presentation today. I have one thing that I said I would come back to. Have I got anything else I wanted to share with you today? Probably, but it's midnight. So I've got one, which this is out of Parkhomov's 225-day core. And the reason I'm bringing it in here is because earlier on in the day, it does seem like it's nearly a day ago, I referred to something in the work of, let me see if I can find it. Okay, I'll give you the trefoil to look at whilst I'm finding it. Yeah. Oh, I love it. Look at that. Thank you, John Hutchison. Thank you. I said I don't want big samples. I don't want impressive to look at samples. I want small samples that you think are interesting. And every one of them's a gem. And I'm only part the way through studying them. Really. No wonder Ken Shoulders spent the last 33 years of his life trying to work it out. Really. No wonder. It's that interesting. It's worth that time. Right. Where did I put that? Okay, so what I was referring to, which is not so clear in this image, but if you can recall back to what I was showing you earlier, it's in this. It's in the other image, but oh no, so slow my computer. Okay, it's not the best shot here. So I was referring to these spheres over here, and because we know we've got calcium in the center here, they're about the same color, so it would be likely that these were something similar. But they're spheres and they're of a certain size. So I'm going to now go back to the main presentation because I've got a little slide at the end I wanted to share. And I will talk more about the analysis of this. But I call this Cupid's bow. It's from the Parkhomov 225-day reactor. And there's some things that I love about this image. Now, Parkhomov's core, as I said before, had silicon carbide in it. And so I think this might actually be silicon or calcium, but anyway, you can look on the scale here, and so that's 20 microns across. And so one of these is 2 microns because there's 10 divisions. And so this is about 1 micron across, but it's an extremely straight thing. And this is probably about maybe 2 microns across, extremely regular diameter. And then this is kind of like the same diameter as this, but it's pairs of spheres and they are helical. They're going, this front side goes around there, goes around the back, comes around here, goes around there, goes around the back. You can see it twisting round over there, comes over here, bends behind over there. So these are pairs of material in spheres that have been dumped into a fibre that is twisting and composed of globular paired structures. And I think this is just beautiful. And when I saw it and I saw the arrow through it, it was like, you know, an arrow through the heart, or your Cupid's bow here. And so there we go. So that is the Cupid's bow. And I think what we've said in this slide and this side, that this is the technology that was known literally all over the world at some point in history, because every single ancient symbol, and if you go back to my presentations as far as 2016, beginning of 2016, you'll see I've referred to others. I would go and look at the stone history and start thinking what stone masons are actually trying to record for posterity. What is the truth in what they are carving? When I went to India the first time, I came across a Muslim family and I became good friends with them. The religion's not important. They just had this culture in Kerala of passing down the knowledge from person to person, generation to generation, through songs. And they had this competition where they could sing songs and they would finish on a word, and then the next person had to start a new historical knowledge song from the word that the person stopped on. And they went on for about half a day doing this. And I was just absolutely amazed that they'd taught themselves so intensely their history through this process. So even if everything was completely wiped out, as long as there was someone alive, they would know the knowledge to take it forward. They wouldn't have to refer to a book or a carving or anything else. They would know. If no one was alive, then it doesn't matter, does it? So, but if you weren't sure that, you know, people that know the knowledge are going to survive, you would carve it in stone. And so what I tried to get across in this is, in part 1 here, is that this is the power of the sun, and it has the power to completely turn matter into whatever, what you might call it, proto-matter, or I think the alchemists had a special name for it. And then you can reconstitute it into other matter. And it is, in my view, ball lightning and coherent. You could say matter nuclear transmutations, but it's just easier to say coherent nuclear transmutations. I think essentially sums up everything. And you can remake matter, and this is the structure, and every major civilization on Earth knew it at some point, and there is some symbolic evil, which I don't think is so symbolic. I think there's a genuine evil that knows this technology, and I don't think it's necessarily an individual, it's an evil. And you are in the position to know that this is the truth, and to see that we see that new sun, that new day. And I'm going to close out by answering some questions, and then I'll play my brother's song because I think it sums it all up quite neatly. So hopefully without any distortion this time. Like I say, I will clean up the audio a little bit as much as I can do, and I'll put titles over it and separately post it. Okay, so have you got any questions? Yeah, Gordon, so Gordon is saying that increasing the spin as well as the length of the yin-yang should increase the production of heavier elements. Yeah, essentially, you can think of it like nothing happens if you're just in a fairly stable environment. But if you keep pumping it with bosons, and you can use, as in my Sochi presentation, I basically said a good selection of bosons, but it doesn't matter. You can use light, you can use photons, light, you can use sound, you can use matter bosons, and you can make composite particle bosons, and then you just get them into a state where they can condensate, and they just will. It's just because most of the world is ordinarily not on the same wavelength and not working together, i.e. not of the same wavelength and working in phase, you don't achieve much. But when you get people of like mind working together on the same task, then you can think of it like that you can achieve incredible things. And if you get more people on the same wavelength working on the same task, you can achieve those things faster, and basically anything you want to do. And in this case, you saw with that video that I started with the pair production, and then you feed the evil twin, and at some point it looks like one of them's always white, so it's always getting got. But I believe that either it's burning up in that other one, but it's a good analog, or it gets to a point where there's so much matter in there you get self-collapse or self-compression, as Vysotsky said of SV and Domenko's work in 2003. You get this self-compression, and you effectively then have a boson over. And so, but if you keep it in the stable range, you can put material in, shift it through, and it gets transmuted into iron, carbon predominantly, and calcium. Predominantly those lower scale elements up to calcium, really, and sometimes zirconium. We've synthesized, well, we've seen synthesized zirconium in, for instance, Suhas Ralkar's work. But anyway, so that's that structure. And when you understand that, if you push it too hard, you will get a boson over. If you keep pumping it and you're making lots of small ones, they will aggregate and they will self-organize to a point that they will do the work. And in fact, if you want to know the step-by-step process where this occurs, just go and read the translation I made of Solin's patent from his application from 1992, which was awarded in 97 or whatever. But it's now free to use. But he describes the step. You know, you get these solitons, and they are magnetic charges of two types, and then they aggregate, and they end up by causing unification of the forces, and this blah blah blah. He's put it all in there. So there we go. And yeah, so that's that. So this is why from the beginning of 2017 I said you had to make and break. You have to make and break. If you keep making and keep making, there's nothing you can do to control it. Okay, so or you bleed. You make but you bleed. You make but you bleed. And there's ways that you can do that, and I've described those in detail in the past. Okay, I've just caught a question here. David Batilio, what does he mean by pinched region? I was referring to, let me find it, this, which was I was talking about the fact that we appear to have made a crenellated magnetic sphere in the Ultra experiment, the first SEM data from an Ultra experiment conducted by Alan Goldwater, and I was referring specifically to this crenellated sphere with the pinch on the top here. So you've got like the grains in the crenellations here are moving to a point here at the top. And I imagine it's the same at the bottom, and I imagine that's because there's a north and south here, as we saw in our own work here, where they seem to be all aligned along this axis. And so I would believe that it's these are coming off more like magnetic particles do, but this is the main axis of these magnetic particles produced in the, and they're again crenellated sort of magnetite structures. As was observed in the Hessdalen ball light impact zone. So there we go. Dan Retty, I've got to point out one wire electricity has been known since Tesla at least. Yeah, yes, one wire electricity has been known. There's a difference between oscillations and passing the resonance down the wire and ball lightning traveling down the wire, and so the effect of ball lightning conducting down a wire is what I believed caused Tesla's power station to blow up. Same with Chernetsky. Same with the transformer of John Hutchison, and same with what I witnessed and recorded in Suhas Ralkar's lab. And I believe that it is these exotic vacuum object clusters, these electron condensates, that are able to conduct in the wire, or they are guided by the wire, but when they get into an inductor, they dishevel, and the collective body then becomes individual electrons, and they produce a current surge, and that blows up the device. Okay, Chris Scott, excuse the ignorance, but what is the reference to Ode? Okay, so Ode is it'll be for you when it happens. I will specifically say the things that I believe O represents, possibly on Sunday, but definitely before the end of next week. That's my goal. But it was a presentation that I wrote of well over 100 slides at the beginning of 2018, and the first tranche was shared in Sochi in 2018 because I felt they were ready. But I wasn't happy with the standard of evidence to argue all of the points, and I wanted to get to a point where we had a series of experiments that were so trivial to do that you would actually have to be trying not to discover anything, or it's not discovery. As I said, this is all a realization, because all of this technology cannot be owned, and it is something that is our species' birthright, and actually all intelligent species in the cosmos, and it needs to be respected. It needs to be respected as total respect. And I will tell you that if you make too much weapons of this and you deploy those weapons, because of what it does, the intense magnetic interactions and the way it plays with magnetism, I believe that you will cause problems for the magnetic pole on the Earth, and the location of the crust, and it's locking to that pole. So this has to not be made and used in that sense. And I think if you did use it to reset the planet, you would end up by causing a pole shift. And it's totally possible, in my view, to do that. And so that's almost why it's more important to get an awareness out there of the reality of this technology, and it is just unimaginably awesome. It's like when you see the first plane fly, you can imagine what is possible. It's like when you see the first rocket go into the upper atmosphere, you can imagine what is possible. It's like when you see the things that this can do, and you can see that it works on every scale, then you know it's all possible, and it needs to be respected. And so it's been a slow process, because only when I've been certain about certain things, and there's enough evidence there, and in addition, I wanted to find out if anyone had noticed this before, because these things can't be chance, that they're happening in everything, and it's like all the same thing. So I was convinced it would be impossible for me to have been discovering this. It had to be just I've realised that this is there, and so then I just needed to see if anyone else had realised it. And so August the 22nd last year, when I discovered Solin, that was amazing. Second week in October 2018, when I realised what Matsumoto had done. I mean, Matsumoto was so far ahead in the public space of knowledge of this technology. And of course, John Hutchison. I mean, John Hutchison and Ken Shoulders were far ahead, but the patent was obscure. No one would know to look for it. They wouldn't necessarily understand it, and the book wasn't made available until a few years back. So, people had a lot of opinions on John's work, but it's real, and what he achieved is effects that you can do every day of the week if you knew what you're doing. And many of the experiments that Matsumoto describes are very simple, actually. They're very simple, and ultimately they achieve some of the things that all of the things that you see in all of these experiments. Jason, my view on giving notice is I try to give notice, but sometimes things come in and I want to get them out as soon as possible, and I decide to just I go on a need to know basis, and if something comes in and it fits in and it must be said before, I will push that out, but I'll push it out as fast as I can, because I want to see I want to get on doing the next bit, and so just doing what I can with the energy I can summon and the support of my family and so forth. So actually, on that note, it's made a big difference. People helping me with remoteview.icu. It kind of just like it's like a couple of coffees a month, but it makes a big difference to how I can respect my family. Let's put it that way. Corky, Tree of Life, yes. Yes, Tree of Life. Because you said that, I'm gonna pull out right now another O-Day slide. There's a lot of slides. Corky has just suggested that the Tree of Life is involved. Now, a cut down version of this slide was in my SWIFTBIC presentation. But this is the original slide from O-Day. So I'm going to drop it in here at the end. So thank you, Corky, for seeing the significance here. So this is slide 52 from O-Day. Like I say, most of it was shared in SWIFTBIC, but the one bit that was missing is the Tree of Life, and here it is. Ta-da! So down the bottom you have shoulders here, and this is the structure, and there's the dark spot in the middle, and you have these substructures, but they can break and they move out and they make these tree-like structures. Here's a less spectacular one, but when they die, they end up by leaving a lot of carbon on the end. And here this is, I think this is from Moscow Nuclear Physics University. And this is a 5-point, just like we saw a couple of times today, structure. That this is, I think, a tungsten on the supposed inside of a tokamak. And there's been some sort of plasma instability, and it is struck here. I would prefer to call this a EVO. And the EVO has gone and done its merry business, and Ken Shoulders called this wildfire. This is the wildfire. And what you end up with is, at the end, you have fleur-de-lis. And the fleur-de-lis are giving out carbon, which the animals can eat. And there we go. And this is terraforming. This is terraforming. So for me, when I look at this image, I see a deep knowledge of how to use this technology to make a lifeless planet into one that can bear life, or to improve a lifeless planet. So congratulations, Corky. What I want people to do now is to accept that this is knowledge that was known all over the planet. All over the planet. It was like as ubiquitous as the wheel, the knowledge of it. All tribes, all societies across the planet knew of this technology. And they knew it so much so that it was just matter of fact. It was in their artwork. And when you know that that is the case, so much makes sense. A lot of the heraldic symbols of power, the symbols that kings and queens and that had, and that deity used, and these mystical symbols, when you realize that they are all aspects of this technology just codified, as it said, that the thunder god Perun and these hexagonal structures, which are essentially a unit from the flower of life and from the ball under the food dragon, they are the symbol of ball lightning, and this is what frees humanity from Azura, the one that would hide the knowledge and keeps us subjugated. They have the knowledge, but they hide it from us. They have the knowledge, but they subjugate us with it. But knowing this, knowing what it can do, will be able to free us. Chris Scott, Bob, can we test if an electroscalar field is stood up locally to the monopole structure? We need to get better at making the monopole structures. I think that will occur in the Vega experiments. I think we're moving in that direction. We have some incredible things to share with you, and the experimentation is moving in that direction. So I think we pretty much described what strange radiation is. Hopefully we're getting a better understanding how to shield for it and how to avoid creating it, but also how to create it if you want to have certain types of outcome. But one focus is on creating excess heat or direct generation of electricity. So I think both of these are eminently possible. And the other focus, which is my personal focus, is to deal with the three major radioactive sites on Earth, Chernobyl, Fukushima, and Inuitak Atoll. Diodon X, perhaps the evil is a collective subconsciousness. That's kind of what I was trying to get to. The evil is, I've described it. Actually, Andrew Johnson said that, you know, when you start talking about X, Y, and Z, and just the facts, even the facts, you will have these Agent Smiths pop up, and they could be your family, they could be people in your workplace, there could be people you happen to meet in a bar, if you are able to go to a bar. And they will tell you you're nuts, and because they already know the truth, and the truth isn't this. And so when you have a technology that on the face of it, with what we are taught, is so unbelievable and so impossible, and then you are given superhero movies, in my view, in a way to confuse the issue. So like if someone mentions it, you go, oh, the guy's just talking about superhero movies. No, you can do these things as a 5-year-old on your kitchen sink. You know, that's the level of experimentation you have to get to. But as I've said a number of times before, you can lead a horse to water, as my father said, but you can't make him drink. It was his 88th birthday yesterday, if he was alive, and so I felt it very appropriate to share this slide with everyone, with the 2 8s on the 2 prayer balls, the meditation balls there. He was a great man, and I would not be able to do this work for you all if he had not been such a great human. So thank you, Dad. Where do crop circles come from? Someone's imagination, and they use various tools to achieve them. Some of them are mechanical and others are field-based. Thanks, Josh Hennan. If you want to write a comment on specifically what you're referring to, that would be nice. He's saying, please look into magneto-resistive sensors for detection of strange radiation. Conscious energies, we will be absolutely switched from scarcity to abundance. There is literally no excuse for the nonsense about global climate change. There is literally no excuse for global hunger. There is literally no excuse for energy. There is literally no excuse for scarcity of elements. There is literally no excuse why we can't enjoy a little bit more of the cosmos. Okay? But we have to recognize this for what it is. And we have to recognize that it's extremely likely that some numbers of people already know how to do this to a better degree than where we're at. But it's not complicated. The actual basis of the technology is what the environment wants to do anyway. It's what it wants to do. It's like literally begging us to find out. In every single experiment I look at, it's the same thing. It's the same thing. Whatever you try, you just have to pay attention. You just have to look and see what nature is trying to tell you. Don't tell nature what it is. Let nature tell you. And that's what Piantelli told the MFMP in the beginning of January 2015. He also said, I don't know why anyone is discovering anything new. This has all been in the literature for over 100 years. And I think what actually happened was, and I believe that George Eagley is right in saying this, they were very, very close to discovering it in the beginning of the 1920s, or even, sorry, even before the First World War. And many of the scientists, all their support structures were destroyed by the two world wars. Let's not let that happen again. If you can't reliably detect radiation, we've got several methods of detecting it, and we're working on others. The sodium iodide thallium dope detector that was exposed, in my view, to an exotic vacuum object dishevelment in 2015-16 on in GS Global Glowstick 5.2. You can go and look at our site quantumheat.org and look up Glowstick 5.2. It produced this signal, which was had no characteristic X-rays and went up into the MeVs, but was predominantly up to 130 killer electron volts. This looked like a beta burst, but obviously the equipment shouldn't have been doing that. But if this is true, that Parkhomov is right and the Russians are right, that the electronic structure that can carry matter can become in a neutral form, as Shoulders said, and that neutral form, it would appear, one candidate is a condensed cluster of cold neutrinos. They could interact with the thallium-205 in the thallium-doped sodium iodide detector and cause that to do instant beta decay, and this is a known reaction. And it's been suggested for looking at solar neutrinos since at least the 1980s. But if that does occur, it will produce lead-205, which is not naturally occurring other than in unbelievably low trace levels. And that is got like 10 million years. We could examine the sodium iodide detector in 9 million years' time, and it would still have meaningful amounts in there if it actually did some work. So yesterday, Alan Goldwater, and with some support, we sent our Glowstick 5.2 thallium doped sodium iodide detector to another party who believes that they have developed a technique that can detect and discriminate between thallium 205 and lead 205, because basically that mass-wise they're only one electron difference, but on a sort of spectral level there shouldn't be any lead spectrum in there, but there should be thallium spectrum, and it's to look for any spectral differences is one potential way to look at it, and you can maybe even do that non-destructively. So we may have an answer on that, and then you could have a system which is looking into a thallium doped, which might even be more thallium, or a system that has more thallium, and you are looking into there spectrally, and you can see maybe changes in the levels of spectrum from the production of lead 205. So that's one way. Parkhomov's got a detector, and in terms of other strange radiation detectors, I'll talk more on those in the future. So another one, Josh Hannon, is saying if we can't reliably detect this radiation, we'll not be able to use this technology safely. So just again, this radiation, we are exposed to it every time there is a thunderstorm. We are exposed to it every time we're near a fast rotating motor. We are exposed to it every time someone is welding nearby us. We are exposed to it probably every time we use a spark flint lighter. We are exposed to it during earthquakes and tectonic shifts. We are exposed to this by being in whirlpools, but it's the straw that breaks the camel's back, and it's the level of coherent matter that can do the real damage. The Russians studying this, they have done several biological studies with mice and with other biological material. In the case of mice, that if you have mice that have been exposed to gamma rays beforehand and they get exposed to strange radiation, it causes the cancers to accelerate. If they get exposed to the strange radiation beforehand, not at a very strong dose, I guess, because 1 hour on the Shishkin's device will kill you after a while, because it gives you cancer, because it smashes up your red blood cells and causes DNA damage to white blood cells. If you have a little bit before, it triggers the production of more white blood cells, and you are less likely to get cancer. So it reminds me of where I lived in India. In India and Kerala, they have one of the largest monazite deposits in the entire world, and this has very high concentrations of thorium and other elements associated with the decay and of those kind of family of elements and lanthanides and so forth. But so they have, as far as I understand it, for a large community, the highest environmental exposure to natural radiation of any group on Earth, and particularly the fishermen, because they have these black sands, and that has a lot of this thorium in it. I've actually got a sample somewhere. I was going to make a reactor out of that with the monazite or the sands, but anyway, that was in 2013. But they found that these people didn't have any higher incidence of cancer than the normal population. And so I think the body is quite adaptable, and we have evolved with this, but it's too much of anything is not good for you. And that is really the story here. And we are finding that materials do like to capture this. Iron-rich water appears to be one way to decontaminate material or whatever. So you will find that, like, if I damage something with this technology, I would have a water feature to clean it up. That's what I would do. But it would take many years. You certainly wouldn't want to build another object on that footprint, because it might get infected with the exotic vacuum objects that are residually in the ground. So you need to decontaminate it over a period of time. So that's what I would do. You know, if there was an accident, you couldn't, without admitting to the technology, you couldn't go and clean it up with the technology, which is also kind of a possibility. But really, the exotic vacuum objects will dissipate in the ground, and every lightning strike that has ever struck Earth at any point on the planet will be producing bucket loads of these things. So it's just we don't tend to live around it, and I don't think there's any problem really with having a good generator that's some distance underground, and I don't think that there's any real risk in using it to remediate nuclear waste, because you can do it in a controlled way away from any people, and whilst it will cause beta emissions, that will be within the purview on the region of the decontamination work. And so that's what I'll say. Different pick, Bob. I was asking about the Matsumoto paper. Yeah. David Buttilli is talking about the Matsumoto paper. He's basically plasmas cause a pinch, and so you can see this very clearly in the Bogdanovich work. So go and look at Bogdanovich, the Moscow nuclear physics laboratory, and in his water flow discharges, you have the discharge and it comes down to a pinch. So, and he's just saying it's the same thing, but the anode's in a different orientation. Alchemy, this is a comment from Bob K. Alchemy is a science beyond physical existence, of course, so not easy to define. I think it's basically electronuclear regeneration, which comes after electronuclear collapse, and you can resonantly, or with giving it seed crystals, in my view, help guide the re-emerging proto-nuclear material into whatever material elements you want it to become. But ordinarily, because these structures tend to follow several rules, they will tend to move in our pressure and our gravity universe. They will tend to produce, in my opinion, the elements that are in the Earth's crust in those proportions. Yes, John, we do need active sensing. So we're working on both shielding and active sensing. Of course, knowing how to, what Dave has done and other things that we've been trying. So the early work was to try and produce very large neutral EVOs and see what they did. And I will talk more about those, but you can look at the very first Vega videos where we've got a thing called Vega Evo Blaster or something like that. And so these are events that are occurring on the cathode. But they're, you don't see anything, and then there's just a big hemispherical explosion. And this causes apparently it appears to cause an EMP as well. We chose to put known elements in LENR to be susceptible to promote LENR, particularly potassium, it being the second most unstable isotope after uranium-235 of all the primordial isotopes. I've discussed this at length over the last several years as to why I believe that's the most important element. And to give credit, I'd made these suggestions only to find that it was already in Parkhomov's book. And he says that potassium is the fuel of the future. It's certainly the trigger of the future. And that with tungsten, which, if you think about it, it's a long, unstable element if you get it anywhere near one of these structures, and it would just eat it for breakfast, which it does. And we demonstrated that in multiple experiments, particularly with both Henk and Dave, but Henk's work has been seminal in just doing that every day of the week, in terms of you can see what it's doing and how it's doing it. Consciousness factors into this, Corky. As far as I understand it, Rife technology is mostly looking at scalar resonance, and it's used for dealing with pathogens is one of the key ways. So a particular bug or a virus. This is Dan Moretti's question, and so it's basically finds the resonance of a particular bug, be it Heliobacter or I don't know, Staphylococcus aureus or something, and they just blow up. So it's like a targeted weapon for things that you don't really want in your body. I know you can. They claim being able to use the same for almost any ailment, the whole universe is frequencies, and when you have your consciousness telling part of your body to do something, it does that through a frequency, and you will inevitably be able to find out what that is through some means. It exists because it exists, and therefore it can be copied and replicated. So quite possibly. Do you agree that the spheres of transmuted material is an image of the Evo that created it? Yes. Yes. And actually, commonly, for instance, in the work of Slobodan Stankovic with HHO gas and carbon, and in the work of Klimov, Anatoly Klimov, in his spin plasmoid reactor, he sees spheres, but the spheres are hollow. And I indicated that might have been the case with one of the spheres, that the sections of iron-rich material that Alan found, and it might be these granulated spheres are actually hollow inside. Particularly, also I think Sergei Godin also, in his Vychev experiments, where they have a copper electrodes and they put dirty water through and effectively create ball lightning, and it does its job. I think they get hollow spheres as well, which also later emit strange radiation, interestingly enough. So the hollow sphere might be as a result of the coherent matter structure. I think people are going to be amazed when they see what I hope to share soon, the SEMs of the Vega Valley. It's really special, really. It details, it really shows you how this, as Ken Shoulders puts it, it's a fluidized electrons, how it can actually structure matter, and it, how it can organize itself. How do you think the ancients discovered this technology? I think in 2006, Ken Shoulders said there's no reason why the Egyptians couldn't have done this, because they had beeswax, cat's hair, and copper. We know copper is very important, and the next series of experiments that we're doing in the Vega experiments will be employing that. And obviously we've got copper in the brass plates that ended up by producing the Vega Valley and other very interesting materials. Cat's hair is keratin, and it's a static producing material. The Egyptians revered cats, and I believe that this is part of it. And beeswax, you know, it's a an insulator. So between those materials, Ken Shoulder said there's no reason why the Egyptians could not produce exotic vacuum object based technology. So I think it was probably by chance and observation, and that's what's happening here now. You just have to use your eyes and your other senses and think critically about what you're seeing. What is it trying to tell you? Is this really just detritus? Is this really just dust? Is this whatever? Or is there a pattern? And should we be paying attention to the pattern, or are we just looking at clouds in the skies and thinking we're seeing things? You know, it is my assertion that every sentient being will ultimately discover this technology. And honestly, I don't think there's anything beyond this. It is the ability to make matter, transport matter, destroy matter, clone matter. That's a different matter. We'll get on to that another time. But Ken actually talked about that. And once you understand it and know that it is real and that it can happen, it then comes down to the bulk of the good people seeing it for what it is and ensuring that it benefits humanity and is not captured for nefarious means, because you simply can't. This is not a technology that you make a bigger wheel and a bigger car and a bigger rocket without necessarily any consequence. It is. So I have a slide in O-Day, and it talks about the original translation of what Jesus said to about I'm going to get this wrong now because I'm so tired. It says in the Greek, apparently the Greek translation is wrong, or the English translation in the St. James Bible is wrong from the Greek. Supposedly it's meant to say the meek shall inherit the earth. And the meek in English is kind of like a subjugation term, i.e. if you don't raise any questions and you just do what you're told, don't worry, you're going to get everything at the end. It's a big reward, right? But actually, the real translation of it is this: those that know that they have great power, but choose not to use it, will inherit the earth. Those that know that they have great power, but choose not to use it, will inherit the earth. We can literally wipe out this planet with this technology. We can crack it in half. We can turn it into very small dust particles. Or we can inherit it. Really, really understand it at its base level. That is, for me, the level of respect we have to have for this technology. It cannot be used willy-nilly. It certainly is not something you want to allow to become a weapon of war on any kind of tit-for-tat basis. You've seen what these vortexes can do. I would go and ask you to look at the presentation, I think, of Stoyan Sarg, where he talks. It's about nuclear weapons creating a vortex, but nuclear weapons create strange radiation. Go figure. They've seen the same radiation structures coming out of cesium-137. So, anyway, the point being is that the vortices, if you have two nuclear weapons simultaneously detonating, then they can create a counter vortex which will remove the atmosphere from the planet. So you will create a figure of 8 and you will kill all life on Earth. And you can do the same thing with this technology. And that is his warning. Being an atmosphere expert and into these kind of technologies, maybe he's right, maybe he's wrong. I'm not willing to try. Okay, we need to err on the side of caution with this technology. But you can see that if you stop pumping it, this technology tends to fall apart very, very, very quickly and go to stability. So it's an easy on and an easy off, with the proviso that it can create things that like to live in metals for a very, very long time. But I'm telling you, the whole universe that we live in is producing these things all of the time. They're ubiquitous, and even the metals that you already have will have a lot of them in. There we go. Did you see any hexagonal or triangular shapes in the transmuted material? Do you mean in the... This is Axel. If you're talking about the material from the aluminium, I will share, once I've cleaned it up, the data from Alan, hopefully on Sunday, maybe on Monday. There was there was a crenellated structure on the iron spheres, and that's it. He did one test and he got a few magnetic particles and put them in the SEM. So it's like early doors on this, but the fact that it looked like I had the sphere in the middle of my trefoil type hexagonal structure in the center of that, looked like a sphere, and I said that's probably one of these ubiquitous magnetite spheres that you seem to get everywhere. And then that's what he found. More than one. Neanderthal, Bob K, nothing. I mean, just wondered if there's some controversy that I didn't know about. I don't know about controversy. There's facts and misrepresentation of facts. WP for truth, yes, I agree. Even if you have the power to destroy something, it does not mean you should, no. Okay, after I gave my last presentation, I literally had to walk past a police car with with the headlights on. Gone midnight. So I'm gonna probably close out now. So I will put my brother up to sound out. I've turned the volume down, so maybe it's not so bad now. I don't know, maybe I'll sing along so you can actually hear the lyrics. And then I will repost it. And thank you again, Guy, for this song. Okay, so One more time. Take it away, guy. Can you hear that? You can't hear it, can you? What have I done? What have I done? I turned off the audio. Yes. Okay, let's try again. Yeah, it's coming. It's not work, it's play, that's the people's right here. Sitting in the sun, making love, having fun, that's the people's right here. The stifling of technology is a crime. To make something to fail is a waste of time. We should make things to last. Stop getting stuck in the past. We'll feed the world with ease. Reduce the working week. Feel the revolution, the technical solution. Life's evolution, working for a new sun. The system's out of date now, restricting information, enslaves the population, breaking stones. Breaking stones. Reprise.